A very warm welcome from my side. My name is Dennis Gassner. I'm working as a DevRel program manager at Microsoft Germany. I hope you're not confused, as the first slide is kind of a slide with a Microsoft logo attached, but we are currently hosting our Microsoft Virtual Training Week in Germany, which is an online virtual training event for developers, IT pros, IT admins, etc., covering a various range of topics, mainly Microsoft related topics, but as you hopefully all know, also a lot of open source topics, as Microsoft opened up its whole stack in the last years. And what is one very good reason for me to start this today is that we always try to integrate communities into our overall event motions and our other activities. I'm also coming from the community. I'm hosting the Azure Dev Meetup in Munich, for example, with some other folks, and I'm a really big community fan. And that's why I'm really, really proud that we managed to get some people from the cloud native community to do a kind of virtual community meetup right after the first day of Microsoft Virtual Training Week. Microsoft Virtual Training Week is a 4-day event. Right now my slide doesn't change, so you can see the full agenda here. I don't want to go through the agenda. I think one of the most important topics for you would have been the cloud native sessions that we hosted today, basically. Some other topics that you might be interested in is Azure DevOps on Thursday. If you want to register, registration is still open and is of course for free. You can find all sessions and detailed agendas and speaker information under the short URL aka.ms/mvtw. And I just don't want to steal too much of your time tonight, just introducing you to the agenda tonight. So we have a Community Connect session, which we called All Things Cloud Native, which will consist of 4 talks in total. Moritz will kick off the evening with a session about what is DevOps. Nico will follow up with a detailed introduction on AKS, which is Azure Kubernetes Service. Then we will have a session of Florian about remote Kubernetes development with Telepresence. And the last session of the evening, which will be quite late, but we all hope you will stay online for such a long time, will be by Leon about Kubernetes security. Each session will have roughly 45 minutes of content and a detailed Q&A session afterwards. So feel free to ask all of your questions. The speakers are here to answer your questions, and hopefully you will enjoy the evening. And with that, I kick it off, and Moritz, the stage is yours.
Yes, thank you very much. Let me share my screen really quick. All right, I hope you can all see the presentation screen. If you can't, then please let me know. But otherwise, I'm just going to continue. Hello, everybody. My name is Moritz Heiber. I work for ThoughtWorks in Germany, and I'm going to be talking today about what DevOps is in my perception and in my experience. And generally, what I would say is that DevOps is a topic which is striking a lot of the same angles as all the other cloud native topics today, since cloud enables to work with DevOps in mind and with DevOps methodologies in mind. So I would guess that this is going to have some takeaways for folks that are currently working with the cloud or in the cloud or planning on working with the cloud. Just for the procedural sake, there is a QA functionality built into this client, which means you can ask questions during the course of the presentation. We'll have some folks who actually keep an eye on the chat and are also keeping an eye on the Q&A functionality, but I'll try to answer all the questions that you might have during the presentation afterwards. You can also vote on the questions if you think you want to have them answered. But otherwise, I'll get to your questions at the end of the presentation. All right, let's get started and let's talk a little bit more about just a short introduction of who I am. So my name is Moritz Heiber, and I've been a consultant with ThoughtWorks for the better part of the last 5 years. And my official title with ThoughtWorks is DevOps Birth Assistant, given to me by a friend and colleague of mine after I have to explain to her what my daily business is like with our clients, which, at least to her, sounded a lot like a routine of a midwife, or in this case, since I'm male, a birth assistant, and what a birth assistant would go through working in their daily job. And I help our clients conquer digital challenges in the 21st century. while delivering software products, or as my colleague so beautifully put it, after I haven't explained my routine to her, they're software babies. And I've chosen the philosophy and the methodologies behind the fairly ambiguous term DevOps to help our clients build valuable products and help their own customers succeed using their digital products. So the question that I posed initially was, what is DevOps? But I have to confess that I'm doing a little bit of a bait and switch in the beginning, which is I'm going to be talking about what DevOps is not, in my opinion, in the beginning. And I'm basing this opinion on years of experience in the field and working with customers, transforming client environments and leading software development teams. Whereas I've seen a lot of approaches fail in implementing a DevOps culture. And because people don't necessarily have a sound understanding of what DevOps at its core is like, or how you can use it to succeed in your different environments. So let's take a look at some of the established knowledge in and around DevOps by visiting the SRE Wikipedia page, which gives you, first of all, SRE, obviously the marketing term coined by Google, site reliability engineering as an implementation of DevOps. I would generally disagree with the notion that SRE is an implementation of DevOps, but that topic's probably something for yet another presentation on another day. So for the sake of this presentation, let's not argue about the semantics and rather just adopt what I find a rather good description of what DevOps is, with two distinct objectives here, which is cross-team empathy and business alignment. So cross-team empathy in the sense that it's the ability to walk in another team's shoes and therefore understand their pains and needs, which is essential to effective communication and value delivery for your own customers. And business alignment, so generally the ability to accurately determine which part of the product you're responsible for and what value you're contributing to the overall customer experience and the success of your company. And both for me are essential to be successful in a digitally driven business operating with a DevOps mindset. Unfortunately, a lot of businesses these days and people as well are interpreting DevOps in a different way, which is much more aligned with technical jargon and delivery terms. So if you're looking up DevOps in Wikipedia itself and take the verbatim entry, you'll find a very technical description of what DevOps is, right? So you'll find things like monitoring and strong automation and software development and construction and delivery and infrastructure. But for me, that is really a lot. This doesn't really reflect what the culture aspects are of DevOps, which to me are much more important than the technical ones. And it's too simplistic a view of what DevOps can mean for your organization and your infrastructure. And people usually only equate it with tools and technology, because naturally, and I'm one as well, we are all technologists and we're trying to solve most of our problems through technology. Whereas I think DevOps is a challenge which is much more on the human side of things, and organizational and cultural. But since I wanted to go into what DevOps is not, here are a few examples of what I think means tackling a cultural challenge through other means, or trying to fit this into other means. So if we take a look at how we're solving some of the other challenges that we have these days through technical means, let's take a look at how we deliver news, or how we are trying to help folks through like the spoken word transformed into technical terms. In this case, it's reading the news apparently is cumbersome, so we have to make sure that we can also shout for the news, or setting an appointment appears to be cumbersome, so you're talking to something that you could also just write down, or push a few buttons for, or type away on your machine. So all in all, some of the problems that we are encountering these days could also be solved more easily through other means, but we're trying to solve it through technology because I think it's sort of the default way of solving it if you're a technologist. There's also the angle of hiring people which are doing technological things for you, and in this case also people that are doing DevOps for you in a dedicated way. So if you're looking up some of this job descriptions on the internet these days, what you're finding is a lot of people are looking for things like senior DevOps engineers or DevOps engineers, And the general description of these people usually means they're highly educated, they need to be system administrators, they need to know the cloud, they need to be Linux masters, they need to do real programming, whatever real programming really is, despite or in contrast to actual programming or just programming. But you'll find a lot of the knowledge that people equate with system administration or infrastructure administration covered under the term DevOps engineer, because if you would have written system administrator, it probably wouldn't have the same appeal because of the ambiguous term DevOps behind it. So for me, this doesn't necessarily reflect what DevOps is. Just because you call yourself a DevOps engineer doesn't necessarily mean you practice or preach what DevOps is. It just means that you're capable of, for example, administrating a cluster or working with the cloud. But then you could also call yourself a system administrator or a cloud engineer. You can also do the same thing if you're delivering DevOps at scale for other customers, right? So you have a lot of companies like this one, as an example, which are delivering DevOps as a service. So for them, it means automating end-to-end delivery pipelines across cloud platforms for faster time to market, increased efficiency, and reduced cost. So if you would have a bullshit bingo right now in front of you, you would probably say, okay, that for me definitely constitutes a bingo. And you'd be successful in that as well, because there's a lot in there which people are taking in order to make money with terms that people associate with success. The same goes for tooling. So if you're praising your own tooling today as a DevOps tool, which some people do, so these, for example, are a few tools which are generally associated with DevOps or DevOps terms, then you would probably come to a point where you're selling it because you've associated the name DevOps with them. So people assume that if they're using them, they're doing DevOps, or they have adopted DevOps somehow. But generally, that's not the case whenever I see this with customers, right? Just because you're using Git or Ansible doesn't mean you're actually doing DevOps. It just means you're fond of automation or code check-ins. And you can extend this list, as far as you want to, right? So you have a few other tools on here like Terraform or Lambda or Docker Swarm or Kubernetes. So people expect that if you were using these tools, DevOps comes as an added bonus because it's marketed that way. But I can tell you from my experience, again, that's not the case. You don't do that actually, because then this is what I tell most customers is you keep using the word DevOps, but I think fundamentally you haven't actually understood what DevOps means at its core. And this is why you're rather looking for easy ways out. So buying DevOps or hiring people for doing DevOps, or buying tools for doing DevOps, than actually digging deeper into what the methodology means or the philosophy for your culture. So let's in order to find out what it actually means, let's circle back a little again to the initial, or let us remind ourselves of the initial definition that I showed before, which is cross-team empathy and business alignment, right? So this is the core focus of what DevOps means. So generally, if you look for it, then you would say that you can't specifically hire DevOps because it's a philosophy, right? So hiring people in a dedicated way to have a DevOps team does not mean your organization practices DevOps or your developers are practicing DevOps. It just means that you have a dedicated team now that is essentially a rebranded system administration team. So you can't hire it in a dedicated way. You can just practice the methodologies or adopt the philosophy. And this is also why you can't buy it. You can't buy a tool to do DevOps, or you can't buy something else and you will suddenly miraculously practice DevOps. Culture, which DevOps should be a part of, evolves and grows naturally and organically throughout your organization. And you have to foster it within your culture in order to adopt the principles. And also, DevOps is not a dedicated tool. Just because you're using Jenkins does not mean you're practicing DevOps. DevOps is something non-technical. It's associated with your culture as a philosophy. So in the end, DevOps can help you deliver faster, but that's not all of it, right? It can do a lot more for your organization than just deliver faster. It's not just something that is associated with that. So overall, what is DevOps then? I get asked this question a lot, and usually it's whenever I'm talking to our head of marketing and head of demand as well. So this is our head of demand. Some other would say this is our head of sales. So people that are looking actively to help our clients deliver products. And what I do is I do client assessments for our demand team, which means I try to accurately indicate what the level of involvement is that we are going to have in order for the client in order to help them deliver faster or more efficiently, and what the measures are that need to be taken in order for us to help them. And so the conversation usually goes, so what about the client that you assessed last week? And since I have DevOps, I'm DevOps Burst Assistant, that usually also revolves around the question, what do we need them to do in order to adopt DevOps? And this is something that I tell them frequently, like 90 to 95%, I tell them, this client doesn't have a technical problem. The challenges that they have from a technical perspective are solved. They have an organizational problem. This means the way they collaborate, the way they communicate, the way that they are actually producing value, the way that they're integrated into the value chain, the way that their products are designed, the way that they're integrating feedback. All of that is part of it. And this is why they have problems right now to realize the full potential of a digitally driven business. So I've written this marketing slide for a specific purpose, I think like 3 years ago, but it still stands true, because what I see on this slide in a nutshell gives you what we are propagating in terms of what DevOps means for an organization. And DevOps is more of a cultural shift within your team or within your organization than it is a dedicated tool or process. So DevOps is not a single team. It's not a DevOps team or a single engineer like a DevOps engineer. It's allowing engineers to collaborate and share knowledge on a bigger scale and making them aware of the bigger picture that they're in within the organization, and then allowing teams to work autonomously and agnostic to be able to realize their full potential. And single purpose homogeneous teams are not fulfilling that promise, right? So if you have just a team which does a single thing like backend engineering, you're not going to be able to realize the full potential of what it means to work with a cultural phenomenon like DevOps. The second part is to realize that culture is as important as the code that you write. So if you're not actually gardening, in a sense, your culture along with the code that you write, it's not going to be able to live on its own, or you're not going to be able to establish a culture of responsibility and trust within your organization, which is hugely important if you're trying to harness the kind of benefits of what DevOps brings to the table. So within your development process, it's all about ideating and writing code and testing and releasing in a more meaningful way. So for that, you have to empower the individuals and teams to focus on what gives you the most value and drives your business at the same time. And all of that, in the end, is being done through trusting your code more, and trusting your organization more, and trusting your people that you're paying a lot of money for more. All of that, usually when we're propagating this with clients, is done through agile software development and building small, incremental, well-tested software, which allows for shorter feedback cycles. It means that you trust more in what you deliver, and you can also course correct whenever feedback arrives that might not necessarily fit your overall agenda from the very beginning. These are 5 things that, from my experience, if you want to go down the route of adopting DevOps, are the most important to start off with. And they're not immediately apparent, which is why I'm going to go through them with different steps and going to explain what I mean by each of these individual steps, and also give you examples later on, because they might mean different things for different organizations, but generally what you should be looking forward to is something which is immediately apparent. The first one is reducing organizational silos. What does this mean? So if you look towards the book, The Phoenix Project, written by the excellent Gene Kim, Kevin Bear, and George Spafford, what reducing organizational silos first and foremost means that you establish the 3 ways, which is system thinking, amplifying feedback loops, and a culture of continuous experimentation and learning. So you're breaking apart the core of your organizational structure, and you're establishing a way for people to continuously improve, gather feedback, and think of the systems they're working on in a way which provides more value than before. Let's take a look at systems thinking in the very beginning. So systems thinking is about emphasizing the performance of the entire system you're looking on. And system in this case means any system. It could mean the system your team's working on, the system your department's working on, the system of your organization, or just a small part of another product that you're working on. So you're not taking a look at a specific silo within a product. You're taking a look at the whole product, and a team is working on the whole product, not just parts of it. What does this mean? It means you have to understand from the very beginning what your product's like, what your value stream's like, and the success criteria that your product entails. So how does your product actually make money? What are your customers' expectations? So on and so forth. You have to identify and you have to leverage the most important contributors to delivering value for your customers, and that at every level. So it's not just about thinking from A to B, it's about thinking from A to Z and what each and every step within this alphabet actually entails, and how you can harness each and every step in order to make it better. You have to champion autonomy and collaboration, because with a top-down model, you will never be able to realize the full potential of what your teams are capable of. If your teams are not autonomous, or if your teams don't collaborate effectively, you will never be able to realize what a product means from a value perspective from one end to another, and also for them to take ownership and trust in what they're delivering. And part of it obviously is also not blaming them for the defects that you will see in your products naturally occur, because blame does not lead to overall success. What's more important actually is to make sure that you're able to closely identify what's most important and then solve the issues at hand with the help of autonomy and collaboration. And last but not least, if you're thinking about systems, so one system over another, the most important part here is also that you're tackling what is called flow control. So flow control means tackling impediments according to their specific priority. And flow control was first introduced in a book by Elijah Goldratt, which is called The Goal, within the theory of constraints. So you have to identify a specific constraint within your system. So for example, within your product or your team, you have to exploit that constraint. So you have to really make sure you understand what it is, and you have to really make sure you understand what the overall value chain associated with that constraint is. You have to then focus on that specific constraint and elevate the constraint to another level. Because what you do is, with flow control, you start at the lowest common denominator. So at tiny problems. And once you've solved all of the tiny problems, the only thing you've left are more complex problems. So what you do is essentially you solve the tiny problems first. You are elevating the flow. So once the trickle has become more of a flow, then you move on to higher tier problems. You solve those problems, and so on and so forth, until the whole chain basically has been resolved, and you're able to you're able to utilize the full flow of what you're delivering towards your customers. So if you're thinking about all of these different steps, then you've realized what reducing organizational silos actually means. So more autonomous, more feedback, less blame, more trust and ownership, and making sure you focus on the things that impede you the most, which are the tiny bites along the path, and then actually take a look at the harder problems in small incremental steps. The next thing is shortening and amplifying feedback loops. Why is this so important and necessary? So it's so important and necessary because it allows for you to course correct and adjust along the way as soon as you become aware of a problem. And what feedback loops means is essentially you can't take larger steps. You have to take smaller steps, because if you're thinking of your development path as a junction, and you're going down the wrong way, you wouldn't want to go down the wrong way for several kilometers, but maybe just for a few meters, and then realize, depending on the feedback, that you've actually gone the wrong way and turn around and go the other way. But for that, you have to take small incremental steps, because otherwise you're going to be long down the road and until you realize you've gone the wrong way. And that turning back then is going to be much more expensive in terms of time and time invested, and also time spent on certain things along the path, than as if you've realized it earlier. Transparency in all of this is also key, because if you are not transparent in what you do and what you deliver, you can't ask people for feedback. If you're developing in a clean room for a couple of months, and then you have a finished product which you're trying to get feedback on, you're going to be disappointed, because people won't necessarily be aligned with the same vision that you had initially. Whereas if you're taking that product vision to your customer and you tell them, this is what I developed initially, it's a small incremental step in the right direction, what do you think? And you get feedback through being transparent. It's much more valuable for you along the way, because you're actually building something the customer wants. So empowering customers and stakeholders to share their feedback effectively is kind of woven into this. If you don't provide an avenue for feedback, be it through verbal communication or written communication or through app integrations or by any other means, then customers won't find the time or the need to reply to your request. If you're just yelling it out into the void, but without any meaningful way to get a response, what good is your feedback loop, right? And then last but not least, these two other parts, the sharing of the knowledge and assessing the state of the product at any moment in time, those are more focused internally, right? Most teams that you see in large tier organizations are kind of building the same thing, sometimes over and over again. And the more that you share your knowledge about what you're actually delivering at any given moment in time and how you're solving the challenges along the way, the easier it'll be to find a common way and understanding of what the best way is to deliver. Whereas if you're not actually sharing your progress with other teams, you probably are going to develop the wheel over and over again, instead of just finding a common measure of how you deliver a wheel. And last but not least, if you're arguing about whether or not a way that you're developing something or how you're solving a problem is the right way, arguing about it in an emotional way or by attacking others is never going to lead to success. Whereas if you're defining clear-cut KPIs and you're trying to follow those KPIs, even if they're coming from other teams, you can factually argue that you're making progress, or others can factually argue that you're not making progress and you have to course correct, right? So measuring your success in all of this is as important as the actual steps forward. If you're taking a look back at the initial 5 steps, then you would basically attribute this to implementing gradual changes, small incremental steps and gathering feedback, as I said, and measuring everything. So it's not just about making progress, it's also holding yourself accountable and celebrating your overall success. Now, for the last two, if you're within an organization that is unable to take risks and learn from its own mistakes, you will never actually progress, right? So if you remind yourself of your childhood, the things that you learned the best usually were the things where you got hurt, or others got hurt, or you've actually made the experience yourself. Your parents could tell you 1,000 times that you shouldn't touch the stove because it's hot and you'll get hurt. If you touch the stove once, you probably realize through the sensation of the hot plate that you'll never touch the stove again. It's the same with large tier to middle tier organizations. If you're unable to fail, and if you're unable to take risks, and if you're unable to accept failure as something which comes normal, then progression will never be something, or innovation in that sense as well, will never be something that comes naturally to you. So if you're talking about a culture of continuous experimentation and learning, one of the key things here is to even incentivize that people integrate continuous improvement into their product development lifecycle. So it's not just about designing, building, and releasing something, it's also about measuring against your expectations and then going for another cycle of designing, building, releasing, and measuring, and continuously assessing the state of what you're developing. The same can go for failing fast and recovering fast. So if you're developing something which takes a certain risk, it doesn't matter if it fails. The only thing that matters really is how fast can you actually recover from your mistake. And if that is a guarantee, or if that has a defined process, it doesn't matter as much if you fail in the process. It just means that you have to make sure that the ideal state that you've defined can be reestablished in a short amount of time. In the end, that can only be done through measuring the success that you have with your product. So this kind of goes in lieu with product feedback and customer integration and feedback from other teams, right? So if you measure your own KPIs against what your expectations are, and you have clearly defined what your expectations are, then you're able to measure your overall success of your progression. And that's really important. And in the end, the human side of it plays a huge part. If you're within a team that can't celebrate their own success, then you will only be let down by your failures instead of celebrating your success overall. And this will make sure that you can actually achieve your own goals. I mean, within each team, there are individuals who have separate learning opportunities and separate goals within their career, right? So you have to leave room for folks to grow. You have to leave room for folks to actually progress in their own goals as well. So once you actually measure your successes and you're able to learn from them and celebrate these achievements, people don't just grow in terms of product delivery, they also grow as a human and as a programmer or software developer. Last but not least, if we're talking about continuous experimentation and learning, one of the key things that I think is one of the most important parts to realize is that if it hurts, do it more often. And this might seem for some counterproductive or counterintuitive because, as I described before, right, I touched the stove once, I shy away because it hurts. So why would I touch the stove again, right? Well, the thing is, I can't actually help touching the stove again because it won't improve me touching the stove. What I can do is I can change the way that I actually do it over time. And for software problems, it usually means I employ automation. So the higher the pain is that is associated with a certain task, the least amount I'll actually do it. So if something is really easy, I can do it over and over and over again as a developer. It doesn't matter. But if it's really painful to do it because it's a lot of steps and it involves a lot of manual labor, I won't do it as often. So the general consensus is if you need to do something and it's really cumbersome, you have to make it easier for you to go through the steps. So this means decomposing the problem, getting feedback for the individual steps, and then in the end, which is commonly associated with this, you automate it. So by decomposing, I essentially mean you break down the complexity of what you're tackling, right? So you isolate the individual parts of what you're trying to achieve, and you identify the boundaries and interfaces between the different systems you're working with. And in the end, you also reduce the scope of what you're trying to achieve. Not all of the processes that you're engaged with are necessarily something which needs to be done end to end. It can also be broken up, or some parts can go away completely. This is especially true for established processes which have been, in a production context for a long time. You then gather feedback for those individual steps, which means you can accurately assess whether one step is successful or not. And this is usually by writing tests. So these are the core foundation of what you're trying to do, because only if you actually can currently assess whether or not you're successful, you can then move on to the next step, which is the automation. If you can keep the feedback loop of what you're trying to achieve short, it'll be much easier for you to assess whether or not your automation is successful. And that is the overall goal, really, is to make to shrink the pain of repeatedly doing the same thing by automating it through an assured and trusted process that gives you feedback immediately if your decomposed tasks have actually succeeded. I have a quote by a friend of mine who I think says it best, essentially. If you have people who are good at automating, right? And they are automating themselves out of their own jobs, then don't fret, because you can just give them more jobs, right? And this goes the same for folks that are good at automating today. Don't be afraid of automating your own job, because there's going to be a lot more that you can automate at the end. Even if it's just about making it more efficient or providing better feedback or integrating customer feedback, it'll come to you eventually. So that concludes the last two pieces of these 5 steps, which is accepting failure as normal and leveraging tooling and automation to actually establish these methodologies and the philosophy behind it. So I promised you some examples, and I'll give them to you now. And I think it's important to realize that they're just examples. Doesn't mean that whatever I'm telling you right now needs to be applied to your own organization or within your own context or boundaries in a one-to-one manner. It just means that these are examples of things that I've seen work, and successfully, sometimes even more successful than I initially anticipated. So the first one would be reducing organizational silos, right? And organizational silos you can best actually reduce if you're empowering teams to work in a cross-functional way, which means not just in a homogeneous team with engineers with the same profession, but actually mix them up, give them a product to work on, and then guarantee their own autonomy. Some folks have associated this with like tiny startups within the company, and it's a little bit that way, right? Sometimes even teams have their own budgets, which they have to manage accordingly. But as much autonomy as you can provide to the team, the better it is for them to work out how that trust and responsibility is actually associated with the product and with their own capabilities. Accepting failure as normal, for me, that means observing KPIs and making sure that, for example, your mean time to recovery is something which is included. So the old thinking of mean time to failure, which is you have 100% uptime and has to stay that way, for me is a notion of the past. What you have to optimize for these days really is that the time between a state in which something is not normal and the time between a state where it is normal is as close as as small as possible, and for you to immediately realize when that state actually changes or fluctuates. So that's essentially something which everyone can implement these days, given hugely available cloud APIs or better abstraction within infrastructure layers. Implementing gradual changes, that's something that ThoughtWorks has been doing for a long time, and a lot of our customers do as well, which is agile software development. So agile has been getting a lot of flack, I think, in the past decade or decades even, because what people do with it is the same that they're doing with DevOps. They're taking parts of it and trying to buy their way into it, and they're trying to understand it as something that you can hire, but it's actually something which needs to be integrated within your culture, and you need to find your own way of how you interpret the Agile Manifesto. And if you integrate it into your daily routine or your daily software development routine in a meaningful way, it'll actually lead to more value in the end. And as I said before, right, you can definitely implement gradual changes through Agile software development, because at its core, it's about iterations that you take in this design, build, release, and measure process, which then leads you to better feedback and a better product overall. Leveraging tooling and automation, that is, to me these days, continuous integration and delivery. So CI/CD is an essential part of making sure that whatever you are developing as a product is getting to your customers in the most efficient and effective way. And as often as you possibly can, through a trusted delivery process with testing as its foundation, and maybe feature toggles or canary deployments or beta programs at its very end. If you're not leveraging CI/CD today, I think you're missing out on a lot of the advantages it has over manual processes that deliver into a production context. And last but not least, measuring everything. One of the most established facts and figures about measuring everything is that it has to be taken seriously, not just as a development practice, but as an organizational practice. So fact-driven decisions in an organization means it's not just engineering culture, it's overall culture. If you're talking to a management executive at a certain level and they're working with their gut, then that's exactly where you have to tackle the problem and say, your gut is one thing, but I want to see numbers for the assessment. Because if you're not actually arguing factual, then you will never be able to measure your success. If you're going with your gut, how are you going to say that your gut feeling actually led to success? Is it because a few other unrelated KPIs have improved? No. You have to find certain KPIs that you can measure, and then you can point to the success value that you've actually attributed to that particular KPI. Now, I think what's really important at the end of this is that these aren't things that I haven't come up on my own, right? Some of these principles have been around for over 4 decades, and some of them are more recent. But overall, these are established software development practices, and the kind of delivery practices that we're living today, which are leaning on these principles, are usually best explained in one of these books that you see here right on your screen. And I especially think you should take a look at Accelerate, which has come out last year, an excellent book which gives you the scientific facts and years of experience written up in a single book. And the same, I can recommend the State of DevOps report, which gives you factual numbers that you can base your own KPIs on, which is introducing it to an organization is always easier if you can already point people to specific numbers that other organizations have measured before, and then measure your own organization and see whether or not you can improve with certain numbers and facts. And with that, I hope I've shown you with the presentation just a little glimpse into what it usually means to be in my shoes and work with organizations in order to improve their overall success. And yeah, thank you for listening to me. And maybe we have some questions that I can answer for you right now. So I can see a question from Josh Taylor, and I'll answer that right away. So does the DevOps philosophy only apply to multi-team organizations? Absolutely not. It applies to any size of organization, be it just a small team of 2 or 3 or 4, or a multi-team, multi-tier organization as well. I think it is, given the constraints that you have in a very small team, it's even easier to establish such a culture because the DevOps depends a lot on collaboration and communication, which means the more effective you communicate, the more effective you collaborate, the easier it'll be to establish this kind of culture. And I think what's most important to realize also is that it's not about getting rid of subject matter experts or people having a favorite subject that they're trying to work on. It just means you have to make sure everyone within a team is empowered to realize the potential that you're bringing to the team, and also not being a single point of failure within that team. I hope I've answered that question with that. Then I am going to answer the second one. Does a DevOps have to have an IT background? So I think what Catherine means with this is, does a engineer who is practicing DevOps have to have an IT background? And please let me know if that I've interpreted that question in the right way. So generally, I would say no. Because as I said before, right, it's about cross-team empathy and business alignment, and you can have business alignment despite not having a large IT experience or IT background. We, for example, are leveraging cross-team collaboration through jobs like quality assurance and design and business intelligence. That all goes within the same team sometimes, and it all leads to a better product overall. So I would say it's not required. Generally, people associate it with an IT background, though, because it's closely associated with software development. But as an overall success criteria, I wouldn't say that it is. Then we have you seen DevOps fail? Have you seen DevOps fail because of the size of an organization? Absolutely. I have seen DevOps fail in a lot of different contexts. And size is definitely, and the way the organization is tackling the overall challenge, I'd say, is definitely a part of it. So it is going to be a lot harder for you to establish a DevOps-driven culture or establish DevOps philosophy if your organization is structured in a way which does not support team autonomy or distributor trust. And it's going to be even harder if this is only driven by a single entity. So usually what we recommend for organizations to adopt DevOps is to do it from both sides, so up and down. So you organically can do it from the very bottom, which usually means developers and people working on products, and from an executive level, where you get the buy-in to actually transform some parts of your organization which are not necessarily aligned with the overall goals and examples of what it means to be a DevOps-driven culture. So yeah, size is definitely a huge factor in it. I miss an assistant. Does a DO's assistant to have an assistant? So Catherine, maybe you can explain to me in the chat, if you want to, what you actually mean with that question. Right now, I'm not sure how to answer it, I'm afraid. So I'll just move on to the next one, or I'll leave it up there. Where would you put the line between DevOps and SRE, if there's a clear line at all? There is, to me, so this is obviously controversial, and this is my personal view, and I think a lot of folks have different views on this. But if you were to ask me what the difference is, it's trust and responsibility. So for me, trust and responsibility are an essential part of a DevOps culture, and DevOps team that also works with in a DevOps-oriented way. Whereas if you're working as a development team with an SRE team in the mix as well, you're still handing over certain responsibilities to that SRE team, which is managing your infrastructure and managing outages and being on call. And that might be for some really convenient because they don't want to do on call. But for me, I've never seen such huge success in actually establishing a DevOps-driven culture, were it not for developers who are on call. If you're on call as a developer, the way that you write your code is fundamentally different from not accepting the responsibility in the first place. And therefore also the trust in what you write and the way that you write it and the way that you test it is fundamentally different. So I'd say that is the main differentiating factor for me between DevOps and SRE. There are a lot of other small things as well that I think are different, and there are good things about SRE as well. I don't want to say that I don't like SRE. I like it as a concept. I just don't think that you could call SRE an implementation of DevOps. Then there is Lexi. Do you think I would have a place in DevOps if I have good tooling knowledge but no soft skills or leading potential whatsoever? Generally, I'd say DevOps should be a welcoming culture. And I would say that if you don't have leading potential, that's not required to be a part of an organization which practices DevOps as a philosophy or with DevOps methodologies. I think soft skills, as I said before, cross-team empathy, business alignment, collaboration and communication, and understanding a product as something which goes from end to end, so from the initial inception vision to your customer, I think are very important. And therefore, I'd say soft skills definitely are required. Leading potential, not so much. Matthias Minch is asking, can you comment a little bit on the relation between DevOps and SRE? I think I've answered that question. Matthias, if you don't think I have, please let me know and I'll get to it again. Mark Baumann, changing culture is one of the hardest things to do. I absolutely agree. What is your take on this? Any hints on how you would change the culture in a company or tips and resources you would suggest? So I can definitely tell you that some of the books that I showed you before, so I'm just going to bring up the slide again, sorry. Some of the books that I showed you before definitely help you in finding the initial spark, especially with folks that you need the buy-in of, which usually means management or executive level. I especially can recommend the Phoenix project or Unicorn project because it really speaks to the overall structure of an organization if you understand what they're about. And if you need facts and things to argue by, Accelerate and the State of DevOps Support are the two things that make it the clearest what kind of benefits you can get potentially from establishing a DevOps-driven culture. And then in order to start off, I'd say you have to start small and go from there. The things that work the best is if you are separating a small part of a product and taking it as its own, and then build a team around it, which is structured in a way that it actually adopts these DevOps methodologies. And so a cross-functional team, which can work autonomous without any external dependencies, which can then establish a product which is small enough to be governed on its own, and then go from there and kind of ripple this throughout the organization. So the initial team then can split up into two separate teams and adopt others within those teams and adopt other product parts or even a huge product on its own. And this is what we usually do with our customers, and this is how we establish a DevOps-driven culture. Christoph Osliker, do you think that a successful DevOps implementation can be done without changing the general organizational structure of the enterprise virtual teams? That's a difficult question because it really depends on what the organizational structure looks like already. If it already supports most of the essential parts of what I think a DevOps driven culture looks like, then yeah, it's possible. I'd say that in 80 to 90% of the times that's not true though. So most of the organizational structures and the culture have to change in some certain way or some certain form in order to leverage the value that you could get out of a DevOps culture. So I'd say it's possible, yes, but I haven't seen it frequently established within the wild. Then we have Timo Bartels again. You said earlier you don't like the quote that SRE is an implementation of DevOps. Would you mind to share with us why? I would love to. The problem really here is I think that would be going way too far and not necessarily be associated with this topic. I think that I've given a separate talk about this. You could probably find it on YouTube. And if you can't find it, please just write me an email. I'm happy to send you the slides and a few of the counterpoints that I have. Yeah, otherwise it would be too controversial for right now. Sorry. Then we have, what is the best way to advocate for a change to DevOps culture and organization? So I think I answered parts of this question already, but generally if you are trying to find facts for making the organization realize that they're missing out on a lot of the potential value you can create with a DevOps-driven culture, I would definitely recommend the State of DevOps Support, which gives you concrete, factual numbers for making folks realize that there is things to improve. And otherwise, I would definitely recommend to read Accelerate, which gives you a scientific foundation and background into what it means to work in a DevOps-oriented fashion. And it'll also make it much easier for you to argue in favor of a DevOps-oriented culture, since people, although they still try, rarely ever try to argue against scientific facts, I'd say. Should all DevOps processes be standardized in a big company, or should the guidelines tools be set and teams have flexibility to some degree? This is an interesting topic because I've seen this implemented in different ways. My personal opinion on this is that people tend to argue standardization versus flexibility because they tend to argue efficiency over chaos or spending too much on different tools or different ways of working or whatever, or the transitioning between different teams, for example, for engineers is not possible because the teams have been given too much leeway in choosing their way of working. So I'd say accepting the fact that autonomous teams means autonomy in every part is a core and essential part of adopting this culture. Because if you don't buy into what it means to be working in a team together, because the process is largely been given to you instead of has been naturally accepted into your team, it'll provide a dampening effect on the overall success. And instead, I'm much more in favor of having people realize that the best way of doing something or the most ideal way of doing something will evolve naturally if you're if you have a transparent and open organization, you're sharing your success and your progress frequently. So naturally, if a product is really good, and if you understand your culture as a product in this case, if a product is really good, it'll sustain itself without marketing, and it'll sustain itself without necessarily standardization. So in this part, I'd definitely be in favor of giving folks as much autonomy as they can, even in large tier organizations, and trusting them to make the right move when it comes to efficiency and costs. And last but not least, Christoph, our seeker, nearly every dimension needs to be considered, and there are buzzwords out there like bus, dev, sec, FinOps. Yes, I know. Do you think there is something like a roadmap or trend for DevOps evolution in a direction, including all department stakeholders? So generally, I think the buzzwords that you see floating around these days, those are people piggybacking on the overall success of the term DevOps. You've seen the same happening to Agile, and this is largely more about making money than it is about actually adopting this into your culture or making sure that you can harness the advantages of DevOps. So I think working this way or working in this particular way is much more closely associated with software development than with any other part of an organization, which doesn't mean that it shouldn't be adopted by them as well. Whether or not you still call it DevOps or something else doesn't really make a difference to me, because I see it the same way with Agile. As long as you are working in a way which is more productive and kind of conforms loosely to the Agile manifest, so the idea that stands behind the term Agile, it doesn't really matter what you call it. I think people call things FinOps or SecOps or DevSecOps or whatever because it's easier to put a price tag on it otherwise. Kathleen, I think I've seen that you basically said I've already answered your question, so I'm going to take this away. And I've seen several folks raising their hand, I think. So if you are still wanting to want me to reply to some, please let me know right now. Otherwise, I'll hand it back to Dennis and we can go on with the overall presentations. And I don't see.
In fact, Nico is the next speaker.
All right, then I'll hand it over to Nico. I'll stop my sharing and hand it over to you. Thank you for indulging me. And if you have any questions, I showed my email address before. Please don't hesitate to write me. And thank you all.
Okay, so hello from my side. Let me share my screen. Okay, so should now see my presentation and hear me? Everything fine?
Yes, we can see it.
Perfect. Okay, so hello everyone. I would like to give you a short introduction into containers and Kubernetes and how you can use them on Azure. So talking a little bit about the basics and then going over into how Azure can help you running them. Okay, so short introduction of mine. I am Nico Meisenzahl. I'm working for White Duck. We are a company based on Rosenheim, south of Munich. I'm working as a cloud consultant. I'm Microsoft MVP, Docker community leader, and GitLab hero. And I'm working with our customers and mostly doing Kubernetes, helping them with DevOps and other cloud topics. So my agenda for today. So first of all, I would like to speak a little bit about why we need Kubernetes or when Kubernetes is needed, and then heading into how Kubernetes works. So giving some introduction about Kubernetes and bringing it to a baseline also for the talks after mine. And then I will head over how Azure can help you. So doing a demo and talking about Azure Kubernetes Service, Azure Container Registry, Azure Container Instances, and ending this up with a short demo. Okay, so why do we need Kubernetes? So let's briefly talk about where containers can help, or why we need containers. So containers, first of all, can help us with isolating our processes. So they help us to run multiple applications or multiple services next to each other on one node without any dependencies between them. So you can just run your instance, and the instance itself doesn't care about any other instance or any other process application next to it, which is pretty nice. So you can isolate your processes and only provide them the stuff they need. Then with isolation, the next one is dependencies. So with containers, we have the option, or with container images, you have the options to change the underlying file system of a process. So with this, you are able to really put all dependencies your process needs. Now let's talk about the Node.js application. You can put in Node.js under it, or if you like to build an application in a container, you can put in some SDKs or other stuff. So you have the option to really put in the layer your application needs and to make sure that the dependencies are met. And then we have scalability. This is basically an option to scale out containers. Of course, the application itself needs to support this or needs to allow this. But if the application allows it, you can easily scale out your applications on one node or on multiple nodes because of having the isolation between the instances. And the fourth and last thing is immutability, which basically means every time a container starts, it starts from the container image you provide. So every instance of this process or of this container is looking the same all the time. So you're defining your Docker container or your Docker image with a Docker file, you're putting in all the dependencies, and with this, you are able to have immutable and same looking container instance every time you're starting a container. And with this, you can also restart a container without losing any changes and so on, or at least losing any dependencies, because you're starting a new instance and it will look the same. Okay, but with container, we are not yet production ready. So there are some things we will need to run containers in productions, and with just running containers or just using Docker as we know it will not provide with us. So some of them are around managing, around scaling, and around monitoring your applications, and yeah, to better run them in production. So examples, yeah, you may would like to scale containers across multiple nodes. So thinking of you're running Docker or Docker Compose, you're limited to one node. So if this node doesn't allow you to provide you with enough compute or resources, you need to scale out by adding more nodes. Or if you would like to have you're sure that your instance or your container is running all the time, you might need to add multiple nodes to have any kind of high availability. So with just using Docker plain or Docker Compose, this wouldn't work. Then you need somehow service discovery and load balancing. You know, thinking about your scaling out your application, you're running 5 instances, 10 instances, 20 instances of your application. You need a piece which helps you to do load balancing between those instances. And you also need a piece which allows you to talk between the services. So think about you have a container on the left side and container on the right side. And the right side container is scaled out. So you have 20 instances. The left one needs to know how to talk to these 20 instances. So you need any kind of load balancing and service discovery. Then you need some kind of self-healing or monitoring of your containers. So your system needs to understand when an application is up, when an application crashed, to make sure that traffic is only routed to that instances who are up and looking fine. And if an instance has an issue, a container has an issue, the system needs to know what to do, or at least to kill it and to restart it, or start a new instance. And then we have some advanced topics, like you might want to manage your secrets or your configurations, and you might have stateful applications. So you want any kind of storage management and so on. So with this, you might get some idea what you might need when you're running container in production. And yeah, you might need to get some more data. So I think my camera just had an issue. Let me check. Sorry for that. Okay. Sorry. Oh, okay, I'm back. Sorry for this. Okay, so let's continue. So why do we need, or what tool can us help to run container production? So, of course, Kubernetes. So it's part of my title in my talk. So yeah, it's basically about Kubernetes. And what is Kubernetes? Kubernetes is an open source tool which helps you to automate, scale, and manage your container workload. And doing so with a declarative approach. So you're not only telling the system, please, so you're telling the system, please run X instances of my application. So let's say, please run 10 applications. And then Kubernetes is doing that. So you're not defining, hey, Kubernetes, please do this and that to get to your 10 instances. You're just telling Kubernetes, please start 10 instances and make sure that those instances are running all the time. So this is a nice example of that. So let's say I say in Kubernetes, hey, I would like to run my app and I would like to have 3 different instances. And then Kubernetes will say, hey, okay, I will now start 3 instances and ensure that they're all up and running. And then some minutes later, Kubernetes is saying, oh, an instance died. So I will start another instance because we would like to have 3 running and now you only have 2. So I will start up another one. And this is completely done without interacting of myself. So it's really Kubernetes making sure that those 3 instances I would like to run are up and running all time, or at least nearly all time. Yeah, so some facts on Kubernetes. Kubernetes is a Greek word, so it's helmsman or captain, which is pretty nice for me. So I think it matches pretty good. Then it was introduced by Google in June 2014. So it's somehow old, at least for the cloud native world. It's pretty old so far. It's hosted by the Cloud Native Computing Foundation. And was introduced by Google, but 6 weeks after the project was open sourced, Microsoft, IBM, Red Hat, Docker, and some other big players joined shortly after the first release, and then many different companies as well as humans are contributing to the project. So it's one of the biggest projects, open source projects out there. Kubernetes was not the first container management tool Google built, so they built 2 other ones, Borg and Omega, but those are only running within Google to manage Google's workload, so Google Search and the other Google services. And yeah, with Kubernetes, Google decided to not only build a tool for Google itself, but also for the world out there, and this is why they open sourced or contributed to Kubernetes, to the open source community. And yeah, de facto Kubernetes is the container orchestration tool out there. There are some other ones, but mostly Kubernetes is used at the moment. So let's get me a small introduction about how Kubernetes works, so that you understand the basics of Kubernetes. So when we talk about Kubernetes and Kubernetes workload, we do not talk about containers. So the smallest instance we're talking about, we talk about Kubernetes, it's called a pod. And this is because a pod, or the smallest instance in Kubernetes, which is called pod, can run multiple containers. Also runs multiple containers most of the time. So let me give you some more details. So this one here is a pod. We have in the middle our container, which is the container version or instance we would like to run. So let's say we have a Node.js application, .NET Core application. The application is part of this container in the middle. But then we might have or basically we'll need networking to work with this container. So we might get traffic to the container, or the container would like to talk with another container in your cluster, so we need any kind of network layer. And the network layer in this pod is also based on a container. So the network layer on the middle is also a container. So with this, when we start our application, our containerized application in the pod, we at least get two containers, one hosting our application and the other one providing the network interface. So why is this in two containers? It's basically because you can run some more or other containers within the pod next to your main process. So on the left, we have a container called init container, and the init container can be used to do anything before the main container gets started. So let's say running scripts which provide some kind of environment configuration, or a script which creates tables in the database, so anything you need for the main process, but you don't like to have it in the container or running in the container of the main process. You can put it into an init container, and an init container makes sure that the init container finished successfully before the main process gets started. Then on the other side, we have so-called sidecar containers. Sidecar containers are containers which runs next to your main process. So not like init container, which run before your main process gets started. Sidecar containers run along with your main process. And this helps you to do anything like routing. So if you like to put in proxy in front of your applications, or if you like to collect metrics or do log management, you might think about collecting the logs of the main process in the sidecar and then forwarding to your main monitoring solution. Or let's say you're using a service mesh like Istio, you will need a managed proxy next to your application, and most implementations are using sidecar for this. So they're redirecting the traffic to not route to the container directly, but to route through the sidecar container to the main process. So with that, you can run anything next to your main process. Once again, everything you would like to have in your main presence container, but you somehow need to run it next to it. So if you would just create a pod, which you can do, Kubernetes wouldn't make sure that this pod is running all the time. Because of this, we have some other kinds of resources in our Kubernetes cluster. So here in the middle, we do have our pod, which consists out of one or multiple containers. And then we have something which is called replica set. So a replica set is a resource where I define how many instances of my pod I would like to run. So in this case, if I would like to scale up my application, and if so, how much instances should be created. So in this definition file, I will show it to you later, it's basically saying, hey, I would like to have an instance running, or I would like to have 5 instances running based on this container image. And then Kubernetes will make sure that this is met, so that 5 instances of the container get started. But it's not the replica set resource itself, it's a controller, a so-called controller. There are multiple controllers in our Kubernetes cluster, and the controller, let's pick one. So we might have talk about the replica set controller. So we have a controller which is listen to our resources, and every time a change or a replica set resources is created, this controller is doing something. In case of the replica set controller, it just creates the pod resources. So if we define we would like to have 5 instances, the replica controller, listen to the replica set resources, would then create 5 pod instances. And also the replica controller would make sure that 5 instances are running. So if one pod gets killed and only 4 are running, the replica controller knows that only 4 instances are running because the metrics get forwarded, and I will show you in detail later. So the replica controller makes sure that another instance or another pod resources is being created. Okay, so with that, we can make sure that the 5 instances we would like to run are up and running. So basically everything we need. But we have another resources, and it's called the deployment resource. It's basically the resource you will most of the time will work with. So the deployment resource is just providing another abstraction layer, and basically allow us the same informations. So or provide the same information. We can provide a container, and we can provide how many replicas we would like to run or instances we would like to run. But under the hood, the deployment allows us to upgrade our service. So let's think about your 5 instances running in your cluster, and you would like to update your application. So it basically would like to roll out a new container image version, a new tag. You're changing your deployment definition, provide a new tag, and apply this into your Kubernetes cluster. The deployment will make sure that another replica set is created next to the replica set already running in our Kubernetes cluster. And in this new replica set, a new container or new pod with the new image gets started. And then, based on your definition, the new pods get scaled out, and the old pods in the replica set get scaled down. With this, you have a seamless update, and you can define how this should all work. But in the default, you have a seamless update. The new replica set gets scaled out, and the old replica set gets scaled down. And with this, you have all the time instances running, and you have a smooth update of your application. And this is why the deployment replica, or the deployment resources that we normally define. So we define a deployment, and then the deployment decides based, once again, on controllers, if a replica set needs to be updated or a new one needs to be created, and the replica set then makes sure that the replica count is met by pod definitions. And then there's a kind of software I will talk about later, which actually starts the actual process that runs the actual containers. So with this, we have our workload running in Kubernetes. So we have our pod running, and we can make sure that it's running all the time. If the container or the process gets crashed, a new instance gets started in just some seconds. We can scale out and so on. But we might need to talk to a different application into a cluster. So let's say pod A might want to talk with pod B, and there's some services. It's called, or there's a service which is basically called cluster IP service, which handles this. So with this, a pod, let's say pod A, can talk to pod B, basically through a defined DNS entry. So let's say we have the pods below are called pod B. We can then create a service B and tell the service, hey, all these pods with that definition should get the traffic forwarded. And then our pod A can talk to service B, and service B can route the traffic to one of the pod from the B pods. But the service also knows which of those pods is up and running and does not have any issues. So there are health checks which you can define, and with this health checks, the service can make sure to only route traffic to an instance which is actually working. So with this, you have the internal communication done, and your services can communicate within the cluster. But then you might have also would like to expose the services to make an external application or a user, giving user access to your microservice running Kubernetes. So there are different kind of services you can use. So first of all, we talk about the node pod service, which actually opens up the nodes as a part of its name and provide an entry point for external persons or services. So let's talk, we have 3 different nodes in this example, and on every node, a port, normally a high port, because of security reasons, get open. And if traffic or a request gets sent to this high port, the Kubernetes cluster routes this traffic to the internal cluster IP service we talked about some minutes ago. And then once again, the service is redirecting the traffic to one of the pod instances. Which is pretty cool. This port gets opened on every node in our cluster. So the person or the service contacting our application does not know on which node the application is running. So it's just talk to any node in the cluster, and then the request is routed internally. But it's still not the best option because we use high ports. We somehow have multiple entry points, so we need to think about load balancing, traffic management, and so on. So it's not a nice option to export and service to an user itself. So we need something better. And there's something better. And basically, most of the time, we'll also act with this kind of service, the load balancer service. But the load balancer service is basically the same as the node pod service. So let's step back. We have on every node a port opened, which is basically just IP tables, and the traffic gets forwarded. With the load balancer service, it's basically the same. But on top of exposing the ports on every node, we get a load balancer automatically added. So we're talking about Azure today. So in this case, the Kubernetes cluster will talk to Azure and will request the load balancer from Azure and will automatically configure this load balancer at a public IP or a private IP and define the routing to route all requests to our Kubernetes nodes, which to the node port, to the high port, which then route the traffic to our service in our pod. So it's basically a node pod service with an automated way to put in a load balancer. And on this load balancer, then the user or the external service can just talk to one IP address, and the load balancer knows where to route this traffic. And this is completely automated. So Kubernetes will talk to the to the Azure resources and will request a load balancer for you, will configure it automatically. There's another one or another service which is basically not a service, but it's a pretty nice implementation. It's called Ingress, and Ingress is an option to define Ingress resources in your Kubernetes cluster, and those Ingress resources can be used to define how a request gets routed into our cluster. So options like described here, you can define different full qualified domain name and route them to service A. You can add a context route and route this one to another service, and you can also define any other kind of details and route them to any other service. So you have somehow an option to better define which URL, which context route get routed to which kind of service in your Kubernetes cluster. But you're only defining this one in a with a resource definition, so like creating a pod or a service. In the back end, to get this working, there's an Ingress controller running, and the Ingress controller is just any kind of HTTP server or proxy, understanding those configurations and implementing those configurations. So we're defining an Ingress application, and the Ingress controller is then rewriting these configurations into the configuration of your chosen HTTP proxy. Normally it's an Nginx, but you can also use any kind of other proxies, Azure proxy, Envoy, and so on. So terrific. There's plenty options out there which are supporting this Ingress definitions. And with this, you have granular access and can define which service gets routed or which FQDN gets routed to which service. On the other hand, you can also configure TLS. So you can configure TLS termination inside of your cluster. You can manage the TLS certificates inside your cluster with Kubernetes resources, and you have a nice way to configure all your traffic routing with that. But it's basically not on service. Also, Inquest is based on a load balancer service, so also this managed proxy, which is used to enable Inquest, is also exposed as a load balancer service because this one needs to be available from outside the cluster. Yeah, so a big picture at the end, how everything is working. Here on the upper part, we have the master or the control plane. So everything managing our Kubernetes cluster. On the left side, we have our dev for operations guy talking to the API server. So the API server, this kind of tool process we are talking to, or nearly everyone in the Kubernetes cluster is talking to. So when we create resources, we're talking to the API server. Then we have those controller manager, as I said, replica controller manager, deployment controller manager, acting on those resources in the API server. We have the scheduler. The scheduler is the process which decides on which node in our Kubernetes cluster a pod gets scheduled. Based on the matrix of the cluster, it defines the information, put it back into the pod resource, and just write the information back into the API server. The etcd is just a key value database where the API server persists its state. And then on the lower part, we have the actually worker nodes, which are hosting the workload, and there the pods are actually running. But we have the other components. We have the kubelet, and the kubelet, that part I talked about earlier, which access or also listen to the API server and waiting for new pod resources. And every time there is a pod resources with the node definition the kubelet is running on, it's starting an instances of this pod on the node. CDadvisor just sends back metrics and other information about the node into the API server to allow scheduler to decide which node should be used for a new scheduled pod. And then we have the kubeproxy, which is just the external part of a node which gets the actual user traffic from outside the cluster. Yeah, I also talked about the resource definition. So you can define them in YAML or JSON. Just an example on the right. As I already mentioned, we have a kind of deployment here where we define our replicas. We would then define our container, which we like to run. In this case, is based on the Nginx image with the latest tag. And this would then start one instance and make sure that this instance is running all the time. You then need to pass this configuration to the API server. This can be done via multiple clients. I will have some information on the next slide on this, and then gets verified and processed by the API server. Working with Kubernetes with different options. I think the most common one is kubectl. It's a command line tool available nearly any platform, so it's available on Windows, Mac OS, on Linux. And kubectl allows you to work with the Kubernetes cluster. So you can list or get resources, you can create and delete resources, and you can access any kind of API resources and details using kubectl. You can also attach to containers, so allow you to attach inside the container and debugging the container, or checking some things in the container, so basically only for troubleshooting purposes. And you have an availability to port forward your into your container, so basically to make the process in your container available on your local machine on localhost, which can also be used for debugging purposes or for development purposes. And kubectl is completely extendable, so there are different plugins out there. You can write your own plugins and extend kubectl. On the other hand, you have a dashboard or multiple dashboards. There's the Kubernetes dashboard. There are also some third-party ones, which basically produce the same information on the same details and same functionality, but with a nice browser-based UI. And if you already work with Kubernetes, you might also know some tools like Helm or Customize, which can help you to actually deploy your applications into your cluster on a production-readier manner than just with using kubectl. Okay, so this was about Kubernetes basics. So let me just check for Q&A for this part of my presentation. We have one question: when routing traffic to a pod, is it round robin, or can I also configure session persistence? So like HTTP clients ending up at the same pod for every HTTP request. So we have multiple options to define the routing with plain Kubernetes options. So round robin is the basic one, but you can also define other ones. If you have really advanced functionality, you can use the service mesh example to better route this traffic, or to route to different version of your applications. So if you like to have, I don't know, 20% to version 2 and 80% to version 1, that kind of routing options. You can do it with Kubernetes basic versions, but I think there are other use cases where also the service mesh can help. But I hope this one answers your questions, but when not, just let me know. Okay, so then heading over to container services on Azure. So what you can do with Azure. So Azure provides you with a container registry, so a place where you can store your container images. It's fully managed and fully scalable. So it's a managed service. You don't need to update it on your own. It's fully managed. It's completely integrated with Azure AD. So you can authenticate with your Azure user with the Azure credentials. You have granular role-based access control definition. So you can define who is allowed to push an image, who is allowed to pull an image, who is allowed to delete images, retake images, and so on. It's just also a nice feature is that the Azure Container Registry and the Azure CLI together allow you to build containers without having any kind of local dependencies. So you can use the Azure CLI like the Docker CLI and doing a Docker build, blah, 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 just with the Azure CLI. And this will then upload your code as well as a Docker file into Azure Container Registry, and Azure Container Registry will build this image for you. So no need to build your images locally or on your CI/CD runner. You can just let Azure Container Registry build those images for you. The container registry also supports OCI images, which basically allow you to store other things besides just container images. So with OCI images, you can also store your Helm charts and things like this into your registry, version them, text them, and just use your container registry as an artifact store. Pricing is based on service tiers and usage. So basically, if you would like to have any kind of advanced features, and I will show you some in a second, and how much storage do you need, how much build time you need if you would like to use the container build option. And it also integrates with Azure DevOps, of course, and also GitHub Actions to use the container registry to build your images. So some advanced features, you can also integrate container image scanning. So the premium tier version of container registry support this, but you can also add some third-party tools like Aqua or any other solutions out there to scan your images before those get published in the container registry, and therefore before they can be deployed or run in your Kubernetes cluster. Other nice feature is geo-replication. So if you have a geo-replicated environment, maybe running multiple Kubernetes cluster in different data centers, so let's say you have one running in US and one running in Europe, you can deploy a container registry next to each of the Kubernetes cluster with geo-replication to make sure that the container gets started pretty fast, so that the image does not need to be downloaded from a different part of the world, so that is next to your Kubernetes cluster and can download it and start it then pretty quickly. And this is completely abstracted from your side, so you're just building a container images, and Azure will make sure that the container images are pushed to the different geo replications. So next to Azure Container Registry, we have Azure Container Instances, ACI, which is a, let's say, serverless option to run containers. So with this service, you're just thinking about your container images, telling Azure, hey, I would like to run this container image. And that is it. So you don't need to care about the underlying OS. You don't need to care about how you could scale this out. You don't need to care about VM sizes and stuff like this. So it's just defining an image, defining a tag, defining the resources the container should have, and starting it and running it. So this works with Linux as well as Windows and GPU workload, and it's a pretty nice service to use with event-driven applications or data processing jobs. So anything which does not need to run all the time, so just need to do one job and then stops again, or doing jobs every night on a scheduled basis. So it's pretty nice for those event-driven or data processing jobs. And which is also a pretty nice feature, that you can integrate Azure Container Instances with your Kubernetes cluster, which then allows you to really fast scale out or to isolate your compute. But I will have a detailed slide, detailed picture on this later. But it's a pretty nice option to integrate Azure Container Instances with AKS. Yeah, once again, Azure Container Instances is pay-as-you-go. So it's based on the CPU and memory your containers need, or you define, I can of course define the limits, and then you pay it as you go. In general, Azure Container Instances are a little bit more expensive, so I really should only use for applications which do not run 24/7. Of course, can use it therefore, but then it would be more expensive than using other services out there. Yeah, with that, we are coming to Azure Kubernetes Service, which is a fully managed Kubernetes cluster, so we don't need to care about any kind of updating your Kubernetes version, making sure that your control plane is high available or anything like this. So it's fully managed. You don't need to think about any kind or anything related to the controller plane. It's scalable and secure by default. So it's high available. You can scale out your node as you need them. You can auto scale your node. You can manual scale your node. All the security best practices are mostly enabled by default. So you need really to opt out if you would like to disable security feature, which is good for new people starting with Kubernetes. That they have a quite good security level. It runs Linux, Windows workload, and also CPU-based workload. So if anything related to CPU workload, you can also run it on Azure Kubernetes Service. And it's pretty nice integrated with Visual Studio Code or also Azure Dev Spaces, which is a nice way to develop on Kubernetes, or at least move some of your development workload or dependencies into your Kubernetes cluster. Pricing is also based on compute. So you need to define your VM sizes for your worker nodes. There can be different sizes. So you can define different node pools with different VM sizes. And then you just pay for those virtual machines, the normal virtual machine price. And the whole control plane, or the master part I showed you in the big picture, is free of charge. So you don't need to pay for anything there. You're just paying the compute which you need on your worker side. So only the virtual machine sizes you define, you need to pay. Everything else is free of charge. Yeah, so AKS of course integrates perfectly with the other Azure services. So for example, Azure Monitor, which can help you with your monitoring, but I have a slide on this later, as well as Azure policies for governance topics, Azure Files, Azure Disk for persistent storage of your applications if you need them, Azure AD, Active Directory for authentication, authorization into your cluster. It integrates with the virtual network. You can add an Azure Application Gateway and hire your application include security. You can manage your secrets with Azure Key Vault instead of using the not really secure secrets version of Kubernetes. It's fully integrated with Azure DevOps for CI/CD, and you also get some nice administration options in the Azure portal. So if you don't like to use CLI, or just would like to scroll through some logs or get some information on a pod, you also find a nice integration in the Azure portal. And this is only an overview. Let me deep dive in some examples. So with Azure Kubernetes Service, you're able to integrate your Azure Active Directory and use it for authentication, authorization. And this is completely integrated. So you can decide this Azure AD user or this Azure AD group is allowed to create deployments, is allowed to access this kind of namespace and so on. So you can really define which the person or the group is allowed to do. And then the developer or the user uses kubectl, access a cluster, and then the URL pops up with a secret, and you just copy the secret, open the browser, put the secret in, and then you get the login screen. You can log in with your Azure Active Directory credentials, which then happens that the Azure Active Directory will provide you with a token. And with this token, you can seamlessly authenticate against the Azure Kubernetes Service. And with that, you are done, you are logged in, and all the authorization steps you define in a Kubernetes cluster will start to work. So then you have cluster autoscaler and virtual node feature. So cluster autoscaler allows you to scale based on your workload. So if your workload gets scaled out because of you're getting a peak or anything like this, Kubernetes or Azure Kubernetes Services is able, if you're able to feature, is allowed to scale out the virtual machines to provide you with more compute to actually run your different pods. This just works in this way that if a pod isn't able to get started because of compute is missing, this pod is not scaled or is not started, so it's in a pending state. And on this, the autoscaler acts. So if a container is in pending state because of missing resources, CPU or memory, the autoscaler will go ahead and add a second node into the cluster, or provision a second node, which basically is creating a virtual machine and adding the virtual machine into the cluster. And then when the virtual machine is up and integrated, the pod gets scheduled on this new node and the application of the container gets started. So as I already mentioned, this option, the cluster autoscaler, is used to create new virtual machines and put the virtual machines in the scale set of the node pool, which is pretty nice, but might be not enough if you need to scale out pretty fast. So if you need to scale out in seconds and not minutes, you might need to think about another solution. And this is the virtual node based on Azure Container Instances. So with Azure Container Instances, you have the option to integrate Azure Container Instances with Azure Kubernetes Service using this virtual node function. And with this, your Kubernetes cluster is able to put workload into the serverless Azure Container Instances service, and therefore can scale out just in seconds. So it's nice if we need really scale out pretty fast. On the other hand, you can also use container instances to isolate some kind of workload. So if you have some workload which is pretty needs pretty high resources, memory or CPU, and you would like to run this service within your Kubernetes cluster or on your specific Kubernetes nodes, you can just move it to Azure Container Instances and isolate it. Of course, there's also the need to maybe run private clusters in Kubernetes. So basically running a Kubernetes cluster, but only exposing it into your personal private network and subnets. This is possible with Azure Kubernetes Service. So on first thing, the API server gets exposed into an internal subnet, not with an external IP, which is the basic setting. With this, the API server or API endpoint is only available within your subnet. And on the other hand, you can also expose your services using an internal load balancer, which not get an external IP address, but it's a public IP address, but it gets an IP address from an internal subnet of your configuration, and therefore uses the private load balancer. And with this, your services get exposed only internally in your virtual network, in your Azure virtual network. Of course, this feature is also available for other services. Some of them are still in preview, but should be available pretty soon. So we have the service available for container registry to allow your containers or to also expose your containers or your container registry on the internal, and also for any kind of storage services. So Cosmos DB, storage accounts, blob storage, and so on. Also interesting if you have any kind of stateful applications. Yes, then we have Azure Monitor with the Container Insights solution, which allows you to not only monitor the Kubernetes cluster nodes itself, but also monitor your Kubernetes workloads or your container. It also allows you to forward any kind of Prometheus metrics if your application exposes them using the custom source option below. And you can also put in any other kind of Azure resources, any other kind of managed services, and so on. Azure Monitor can store metrics and log data based on log analytics. And with this, you can then get insights of your applications, visualize them with dashboards or Power BI or anything like this, analyze them, or also put on alerting to get alerted to any kind of issue. And you can also integrate it with any kind of other solution. So you can use Event Hub to forward the data to a Elasticsearch stack or any other stack, and so on. So we can use Azure Monitor as your monitoring solution, but you can also forward the information to any other kind of monitoring solution you might need or might work with. Then pretty new feature is governance with Azure Policies. So with Azure Policies, you have the availability to define certain policies in your whole subscription. So I only would like to run certain container, certain virtual machine types. I only would like to use certain locations and so on. And now you also have the option to governance your Kubernetes cluster. So you can define things like, I only would like to allow certain container registries, or let's say the Kubernetes cluster is not allowed to start container images which are hosted on Docker Hub, or things like this. So you're able to have granular access into your Kubernetes cluster and can define certain policies for governance reasons. Pretty new feature, but it's available for some weeks now, I think. Then you have the Azure Key Vault integration, which is a nice solution to manage your secrets, which you may already have in your Azure Key Vault, but you can also integrate your Azure Key Vault with your Kubernetes cluster, which then allows you to inject secrets or certificates stored in your Azure Kubernetes Azure Key Vault into your workload. So with this, you can inject secrets or certificates into your container workload, as you node, as file, as environment variable, and so on. And the secrets itself are then stored in the on a secure way in your Azure Kubernetes vault, and you can also use them from different services in your Azure world, not only Kubernetes but all other services as well. And with it, they're pretty secret and stored pretty secure. The secret, the basic Kubernetes secret, is also a resource type we can use. It's not that secret, so it's basically only base 64 encoded. There are certain kind of security options in there, but it's not fully secure. So it's pretty nice to have this kind of option with the Azure Kubernetes world. Then there's a pretty other nice option, which is Azure Active Directory pod identity, which allows you to give access or enable your container to access certain Azure resources. So with this, you don't need to create a connection string to allow your container workload to talk with Azure Cosmos DB or any other storage option, and to handle the authentication in your code, in your application code. But with this, you can allow the container to access the Azure resources in behalf of. So you don't need to put in any kind of connection string, any kind of secrets. You basically allow the process, the container itself, accessing this Azure resources, which is pretty nice abstraction layer to not need to configure the whole secret management and connection management into your application. So you can put it out of your application code and just abstract it and configure it with your Kubernetes deployment or your application deployment into your Kubernetes cluster. This is also based on the Azure Active Directory integration and the Azure Key Vault integration. And it's based on node managed identity, which you might already know from a virtual machine-based workload. So it's a solution which is available in Azure for some time now, and now we can also use it with our containers. So with this, I would jump over to a short demo. So we're a bit limited in time. So if you have any kind of questions, please feel free to post them in the Q&A. Then I can decide if we get started with a demo or just doing Q&A. But until I don't see any questions, I will just start the demo. So here I already created a Kubernetes cluster and a container registry up front, because I had the idea that I might be limited in time. So this, we have an AKS and Azure Container Registry. I created them with the Azure CLI. So I'll just give you some details, making this a little bit bigger. So you can use the Azure CLI and then provide AKS, create. With this, you have the option to provide the resource group. So where should the Kubernetes cluster live? You can add the name. You can add the name of the Kubernetes cluster itself. You can define the Kubernetes version, the node size. In this case, I'm creating one node with the size B2S. I define the location, and I define how it should authenticate with Azure. In this case, I'm using a pretty new feature, which is managed identity. And then there's a managed identity created with the Kubernetes cluster we'll use to talk to the Azure resources to get storage, disk storage, or any other kind of storage, or the load balancer to get access from outside. So just need to change the name because we already have this one. So let's say version 2, and then the Kubernetes gets created. This will take some time. So we do not have the time to wait for it. So I will open up a second window, but it's now running and will get created in some minutes. Same again for the Azure Container Registry. This time it's ACR create, and with some less options. Once again, I can provide a resource group and a name. In this case, I just added a random part to the name because the name needs to be unique. I define a location and the service title. And this one should create pretty fast. Once again, I need to change the name. So it should only take some seconds. Oh, okay. The name is already used, perfect. So put in some. So with this, the registry already got created. So if we do a refresh, oh, we see the Kubernetes service, which is still created, and we should see in just some seconds our ACR. Okay, so it's maybe some cache. Okay, so no questions so far? Okay, so with that, I would have some further steps, but I only have 3 minutes left, so I would come back and yeah. So, do you have any questions? Any further to discuss? No? Okay, someone raised his hand. So do you have any kind of questions, or please use Q&A? Okay, if not, I'm happy to move over or move back to Dennis. I will be in the call, so if you have any further questions, just post them in. I will provide answer while the next talk is running.
Thanks a lot, Nico.
You're welcome.
If there are no more questions, I think we can move forward with the next talk by Florian.
Let me share my screen and video. Okay. So you should be able to see my screen now, I hope.
Yes. Perfect.
So, hi everyone. My name is Florian Aßmus. I work for PRODYNA, and I'm in a very technical role. So I started as a software engineer, did a lot of software architecture, system architecture, and have been working with Kubernetes since 1.0. So I learned the hard way. Yeah, and currently I'm basically doing customer projects on cloud native technology, mainly with Kubernetes on different clouds. So that's my background. And I want to give you a short introduction into how you can develop remotely on Kubernetes using a tool called Telepresence. Yeah, so what is the problem domain? There we go, come on. Right. So when you start developing microservices, you essentially develop a distributed system, and where there is one microservices service, there are usually many others to follow. So on the right side, what you see here, that is the microservices network from Monzo, a bank in the UK, an online bank in the UK. So they have over 1,000 microservices now. And as you can see, there are many interconnections, and the state of your application is distributed across multiple processes. So it becomes very, very difficult to manage the dependencies. And as a developer, when you want to get started on one of these little black dots developing, you will probably need a lot of dependencies for really doing development work. So this is really, really a big issue, isolating a single service and starting development on a single service. So for the target environment, usually when you do microservices, you should do it in a cloud native way with an orchestrator in place. In this case, sure, Kubernetes. You have heard all about it in the last talk. So why Kubernetes? So we have a single service here we want to start developing on. It might be distributed across multiple worker nodes, or even on a virtual node in a serverless environment. We have to deal with a closed software-defined network. So within a Kubernetes cluster, you have a fully autonomous software network, because the IP addresses of all these services, they are completely random and assigned by Kubernetes. And getting into the cluster is quite hard. Also, there is service discovery in place. So when you want to talk to different services, you somehow have to discover other endpoints. Kubernetes has mechanisms for that, but it's a quite complex challenge, because the system is always changing and IP addresses are changing, services are starting, stopping, scaling, and keeping track of that. That's the responsibility of service discovery. And also configuration. I have to somehow configure my service now. So my service is running on one of the 1,000 nodes that my Kubernetes cluster has. So I have to get my configuration there. And this all makes up the whole environment of my application. Yeah. There are basically two very opposite approaches to developing on such a cloud environment. So one would be I move my IDE and my development tools into the cloud. You might have heard about Eclipse G, or there are many tools now available that are web-based, and they run on the Kubernetes cluster. So I have the same environment. I have all the software networking in place. I have the configuration mechanisms in place, service discovery, everything is there, and my IDE is integrated into it. On the other hand, we have the local developer machine with the tooling our developers have been using for many, many years and are used to. And what you can do is you can do remote developing. So you bring the cloud to your local machine. And this is what we will be focusing on. So not the right part, but the left side of the picture. The easiest way, I can install my cloud environment or my Kubernetes cluster on my local development machine. Start my service, consume my dependencies. That works essentially. It gives me a very quick inner development loop, meaning changing code, compiling code, running it. It runs on my machine, so everything is like I'm used to it. My dependencies, I can deploy them with the same YAML configuration and the same configuration I have on my target environment. So this is also very convenient. The bigger problem is, how do I get the network traffic in there? As I mentioned, the services running inside Minikube or running inside my local cluster, they have their dedicated software network. So getting traffic in and out is always a bit tricky. Also, the service under development, the red one, Service A, does not have service discovery available. So I have to think about what kind of ports should I expose, and then I can link to them in my development environment. But I don't have this nice service discovery that usually Kubernetes offers me. Also, my service now runs in a different environment. I configure it differently. It's not configured in the same way as it would be when running on my Kubernetes cluster. And last but not least, that's the killer argument, resources on my local dev machine are limited. And I will not be able to run all my dependencies on my single machine. But easy fix. I just run it on a remote Kubernetes cluster. I have kubectl. I can remotely access my environment. I solve my resource scaling problem. But I still have the network issue, and I still have the issue of how my local service I'm currently developing on can access dependencies. So one nice little tool which makes life of a developer easier is KubeForward. So it is basically kubectl port forward on steroids. With kubectl port forward, I can expose services running in my Kubernetes environment on a local port I can access with localhost. That's what kubectl port forward does. With KubeForward, I can say, hey, please expose all services from a given namespace on my local machine, and it will automatically create all the port forwards, and it will edit my hosts file, so I have even DNS resolution. Little drawback, as you can imagine, I need root access on my client machine, but it's very convenient. So this solves some problems, but we will see that there are more difficult problems to solve. And what I can now do is I can to closer resemble my target environment and my development environment, I can move my service inside the cluster. Now I have my dependencies, I can deploy them. Wonderful. Resources are scalable. Now I get the Kubernetes service discovery. I'm within the software network. So everything works like in my production environment. And exactly, my service is running in a container with the configuration injected. So it's very closely resembles my production system later on. And one very, very important thing now is I can do end-to-end debugging and development. So I even can receive traffic on my service and don't have to find a way or figure out how I can create test cases with specific workload or specific header variables and so on. So I can really go into my dev environment and just link into the controller that's routing traffic inside my cluster. So I really can do end-to-end, an end-to-end scenario. The problem with this setup now is that my development, my inner development cycle is slowing down, because now I have to compile my code, I have to package it into a Docker container, I have to push it to a Docker registry, and I have to update my deployment on the Kubernetes environment to pull in my change. So this is really a lot slower than just save and hot code replace on my local machine. Also, now starting to debug this service running remotely is also a difficult task. On my local machine, it's very easy. Instead of just running it, I click on the debug button and my service is in debug mode. And I can step through and everything nice my IDE has to offer. When it's running on the Kubernetes cluster remotely, this is not as easy anymore. So there are different tools available. There's a Microsoft flavor called Draft. It's open source. It creates Helm charts, Docker files based on the language it detects. So it will try to figure out, oh, is it a .NET application? Is it a Java application, Python application? And it will help you to set up all this this Helm chart and Docker file stuff. Once running, Draft will automatically detect changes, and then it will build, push, and deploy your application automatically. So you still have to go through the whole process, but it will do that in an automated way. Same for Scaffold. That's a very similar tool. Now it's the Google flavor. It has some nice features that you don't have to rely on Docker files. You also can use Jib, for example, for not having to run Docker locally. And moreover, it's not it doesn't rely on Helm. You can specify what kind of deployment mechanism you want to use. You can use kubectl, like plain YAML files. You can use Helm if you want to, or customize. We will see customize in a short bit. So they will help you to speed up the inner development loop. But then we still have the issue of debugging our service that's now running remote. So there is a tool called Squash. It enables you to live debug Kubernetes pods, set breakpoints, step through the source code, view and modify variables. It comes with support for different debuggers. So there's Java, there's Go, there's Node, there is Python. And it integrates also with the most common IDEs. So VS Code, IntelliJ, Eclipse, they are all supported. And what it does, it exposes a debugging port locally on your machine to which you can connect. But it requires an in-cluster component to run on every single node of your Kubernetes cluster. And it needs some privileged capabilities to connect to other Linux processes. So how does Squash basically work? So from your local development machine, Squash CTL, you say, oh, please debug a specific pod, and the command will go to the to this in-cluster component. This in-cluster component, now comes the tricky part. It connects to your container daemon via CNI. So it basically talks to Docker. It checks what pods are available. It grabs the PID from the Linux process, and it really connects to the process via Linux capabilities. So this is really escalated privileges, I would say. But once connected, it proxies through the connection, and you can connect to your running pod locally. Is one approach, but on a multi-tenant cluster, running this privileged component is quite tricky and might not be feasible for many of you. So the last option I would like to show you, and that's where Telepresence now comes into play, is you have only a proxy running, a proxy process running in your cluster, and it creates a connection to your actual service running on your machine. So this scenario has all the benefits. You have end-to-end debugging because your proxy can receive traffic and can send out traffic. You have unlimited resources basically on your cluster. You get the service discovery. All your dependencies are available. And now you even get the quicker inner development cycle because you're now developing locally on your machine. You can do that with any tool you're used to. So that's why this approach is really appealing. And you reassemble your service runtime very closely. We cannot do it completely, but we can get very close on your local machine. The setup, if you're running Windows, there are some tricks, and you could use Docker, but Windows is not so well supported, I would say. But if you have a Linux machine or a Mac, everything works pretty smooth. Okay, so what is Telepresence? Telepresence is an open source tool exactly made for this scenario. It virtually moves your local development machine into the cluster. It is somehow of some kind of a two-way proxy. It feels like a VPN, but it's not a real VPN. Everything is going via an SSH tunnel. But what it gives you is inbound and outbound network traffic to your cluster on your local machine. So a port on the proxy is called within your cluster, and the request is routed to the same port on your local machine. And same in the other direction. So you can call other services running in your cluster from your local machine with the same DNS name, because DNS is also going through the connection, the Telepresence connection. Moreover, Telepresence grabs all the environment variables from your pod and proxies them to your local machine. And config map secrets also, because you locally get mounted the file system of your pod in the cluster. It's not very performant, but you get the whole file system, everything is available. So the cool thing now is your development tools stay the same. So you develop with the tools you're used to, everything works the same. Also the debugging. So from a user experience, this is how the scenario looks like. So we have a Kubernetes cluster running, our services are all in place, and we run a command, Telepresence, please swap the deployment from the service A, and in this case, I will run a shell. So now what Telepresence does, it replaces the actual service. It just exchanges the image from the pod, and instead of running your application image, it will run a proxy image from Telepresence. And this proxy will connect to your local Telepresence CLI and establish this proxy connection with in and outbound traffic. So it will route DNS into the cluster. So you also get DNS resolution, which is basically the service discovery from Kubernetes. And environment variables, config maps are also reassembled on your local machine. Then you can run your local service and get all this from completely transparent for the local process. Or you can go to your favorite IDE and run your service in debug mode from your local IDE. So that's the user experience. That's how you use Telepresence. How does it work? Telepresence has multiple ways of establishing this connection. So the default and the easiest one is VPN TCP. The name suggests it's a VPN, but it is basically not. So it's an SSH connection, and all the TCP connections and DNS queries on the client side are multiplexed through the SSH tunnel and extracted on the other side from the server-sided component. Both written in Python, and the tool that is used is sshuttle. So you can use this without using Telepresence. They just integrated an existing open source tool for this purpose. So it forwards the traffic only to the defined subnets from the Kubernetes cluster. So your normal internet traffic will still go out through your normal connection, through your normal internet connection. Only IP addresses that are managed by Kubernetes, they will go into the cluster. You can, when running Telepresence, you can add additional IP addresses, IP ranges, or host names. For example, if you use a managed database or something that's not inside your cluster, but you still want to be able to access it as if you were inside the cluster. Yeah, on your client side, for that to work, you require root access. No way around that for this scenario. And it affects all clients and all your processes on your local machine. So this is very important to know. It works on Linux, macOS, FreeBSD, OpenBSD, whatever. You don't see Windows in this list. There are ways of somehow doing it, but I didn't really dig into that. Another way of establishing this connection is inject TCP. This is a bit different. It modifies the libraries from a single process. So That means it will only affect a single process when you run Telepresence. So what you do is you run Telepresence, swap, which deployment you want to swap, and then you tell it, please run the following application locally or the following process locally. And only this newly spawned process will have the connection to the cluster. With the difference now that all traffic is going through the cluster. So even if you just access the internet, it will go through the tunnel, go to your cluster, and from there to the internet. So it's a bit different, but it can solve some issues, and especially you can now debug multiple services or run multiple connections at once. With the VPN type, you affect your whole machine, so it only works for a single service. Yeah. The last option that also works on Windows is that you could run Telepresence in the Docker mode. What it will do is it will run 2 containers. Somehow it's similar to the pod construct in Kubernetes. It will run a sidecar, sidecar container that will establish the VPN connection or the Telepresence connection, and it will run your container you would like to run, and that is connected to this Telepresence sidecar. So only your container is affected, and only within the container you get the environment variables and the network routing and everything set up. So as long as you are able to locally develop inside a container, then it will work perfectly. Yeah. So these are the 3 ways of how you can use Telepresence. And this is how it looks like when you ask for the environment variables are mirrored to your local machine. And as you can see, I run Telepresence, and if you now do env, you get all the environment variables from within your pod. And moreover, you can tell Telepresence, please also expose the environment variables in an env file for Docker Compose or in a JSON format. We can see later on how this is very useful when, for example, developing in an IDE like IntelliJ. Also, based on SSHFS, you get the file system from the pod within your cluster mirrored to a temporary folder on your local machine. So you can access all the config maps, all the secrets, whatever you have mounted inside your container, even volume mounts, persistent volume mounts, you get access to them. It's SSHFS, so it's far from performant, it's very slow, but for reading config files, it's completely okay. The only issue with that is you don't have the same absolute path, because Telepresence cannot mount the file system from the pod to the root folder of your machine, so it has to mount it to somehow to a temp folder, and in this case the absolute file path don't match. The folder to which it is mounted is provided also in an environment variable. So working with that, you can reassemble it very closely to what's in your inside your cluster. Okay, so this is a lot of theory now, and it somehow sounds a bit abstract. And I think it's easier if you just have a look at what Telepresence does and how it actually feels like when you work with it. Our scenario is the following. So I have a service running, hello service, that uses the name service. The name service just randomly generates names, and the hello world prints them out with a hello. So very basic, very easy. The deployment is done via customize. when using Kubernetes 1.14 or kubectl 1.14 and upwards, Customize is built into kubectl with -k instead of -f. You can run the deployment. We will see how this can help us in the development process. So imagine this is my dev environment. I can access it from a public URI. Traffic is routed to my Hello service, and I have a dependency in the back. With Telepresence, I will now switch out the actual service, the Hello service, against the proxy, and I will run the Hello service locally in my debugger. So this is the scenario, and we will even go a bit further, because imagine what happens if I do this on my dev environment, like where my integration environment, and I put a breakpoint in my service. All the traffic in this Kubernetes environment is now blocked because I have my breakpoint, and probably I went home for the day, and nobody else can work anymore on the dev environment. So that's a very bad idea. Other option would be I could deploy everything in a single namespace, but that consumes really quickly a lot of resources. So wouldn't it be nice to have a shared environment where I can pick single services out, start developing them, and via a little flag, maybe tell my services, please use my debugging instance. So this is exactly what I will be doing. I have Istio, the service mesh, running on my cluster, and Istio gives me these kind of traffic shaping or traffic steering capabilities, where I could, for example, say only if the header variable is debug hello service, then I will hit my debugging instance. Otherwise, the traffic is always going to the existing hello service. So I'm not really touching anything. As long as I don't set the header variables, nothing will ever hit my local development environment. Yeah, so this is the target environment I want to show you, and how this all works together. Okay, wait, one back. So let's see. Let's start in my Visual Studio Code. So all the code I'm showing you today is on GitHub. I have the URL is on my slide in the back. So we have the name service, the hello service, and the demo environment. What is the demo environment? That's the part where I define the deployment for my hello service and my name service. I'm using Customize, as you can see. Both services are Spring Boot. That's because that's why I can very easily define a single deployment object with some standard configuration, like the readiness probe, the port, the exposed ports, and so on. My service, everything is defined here in my base deployment. And if we have a look at the hello service, I simply reference my base deployment in Customize, put a prefix in front of it, slap a label on it, on all the objects. So my service, my deployment, they will all get the same label. That's what Customize does for me. And for demonstration purposes, I also put in a config map. So I have a little configuration file that, whoa, has some nice text in it. And it will be patched into my deployment. And also I set an additional environment variable for my name service, where I can find my name service. Because it's DNS service discovery in the cluster, I simply can reference it by name. Yeah. So this is the deployment for my hello service. The name service is a lot easier. It's only I'm doing no customization here at all. Okay, so I have deployed that. We should have the pods running. Here we go. Both both services are running. I should also be able to call my service. As you can see, it returns a random name every time. So perfect. And now let's run customize. Let's run Telepresence. So I'm switching over to my IntelliJ IDE because I want to start development on the Hello service. And Java development, personally, I like IntelliJ, and also it has a nice little feature I will show you in a bit. So I go to my IDE, I have my microservice in the my source code checked out, and I start Telepresence. I can show you what I'm actually doing. I've created a customize file that references my target environment. So I could, from any environment I'm deploying, I could reference the exact YAML descriptions. So no copy pasting here. I'm just referencing my Hello service deployment. That's why I personally really a big fan of customize. So the only thing I'm doing is I add an additional name prefix like debug. And I slap on another label called debug hello -service. So whenever somebody changes something in the deployment here in my demo environment, if somebody changes anything here or in the config file, whatever, this is automatically reflected because I'm referencing it directly. Okay, and my start script is only, please deploy a debugging version of my service, and then swap out the debugging service against Telepresence. And here you can see I also tell Telepresence to please write the environment variables to a JSON file. And as you can see, my deployment has been created. Telepresence needs root access. Now it's swapping out the deployment we just made. So it's just swapping out the container image. Hopefully it will work. Here we go. Okay, so let's have a look at get pods. So we can see there is now a third pod, debug hello world deploy with a unique ID that's created by Telepresence. And oops, sorry. And if we do a describe, pod debug, you can see it now uses the Telepresence image. So it has the same configuration. It has the memory limits are the same. Also the environment. Hello. Are you still there? Okay. And it has the same environment variable somewhere. Here we go. Here is my name service. So everything is the same as the actual service instead of the image. The image has been automatically replaced by the proxy. And as you can see, I now have Telepresence is up and running as long as I don't quit this shell. Moreover, it has mirrored my file system from the pod on my local machine. Let's have a look. It's under my temp folder fs, and if I do an ls, I can see my config folder, and I can cut, check out the content. This is exactly my configuration file I have defined in my YAML definition. So this is really nice. And now I can have a look at the hello env JSON. You can see all the environment variables have been written to the JSON file. And what I can do now, that's why IntelliJ is very convenient in this situation. It has a plugin for end files. I can just say, here is my JSON file. Please, when you run my application in the debugger, set all these environment files, and they take precedence before the my local environment. Yeah, so that's very nice. And now, hopefully we have more luck now, because I definitely want to show you how it will look like. So, proxy is established. There we go. And now my service should be available if I run debug hello world, debug the same command but with a debugging header. And as you can see, it doesn't realize that there aren't any upstream services, or they are not able to connect. And this is what we would expect, because we haven't started our service locally yet. If I call my URL like this, it still will work. As soon as I put in the debugging header, it will fail. And this is what we will do now. In my IntelliJ, I'm just running my service locally. And once it's up and running, here we go. That should be it. And now my service is answering again. And what I can do now is actually the code or the execution is done on my local machine. So I can set a breakpoint, curl my service, and the breakpoint will hit. And the interesting part now, have a look at the variables. So the name service URL is my cluster internal DNS name, and it will automatically, so I'm receiving requests done from my public URL. It will be routed from the proxy to my local machine, where I'm currently running the application in the debugger. And when I do calls to dependent services, they are routed back to the cluster. I get the result back. And yeah, here we go. So I'm debugging my service from within the cluster in a very, very tight integrated environment with the tools I'm used to and the tools I love. So yeah, that's what I wanted to show you. And I hope you took something with and got some ideas for improving your own development lifecycle. Do you have any questions? I will quickly move over to the Q&A. Where is the Q&A? Here. Okay, does anybody have any questions? If not, thank you very much. I hope you enjoyed the talk. And yeah, sure. Well, the live answer. I could also replace the name service, but only one of the services at a time. Otherwise, I would have to reconfigure Telepresence to not use the VPN TCP way of establishing the tunnel, but I would have to use the inject version. And then I could have both running on my local system, and they would route to the cluster and back, and to the cluster and back for the whole call chain. So that would work. Yeah. No. So you need So yeah, yes, it does kubectl exec work for you? And I think that and kubectl port forward, if they work because they are going through the API server, then this probably will work too. Yeah. I hope this answered your question. Okay. So thank you very much. If there aren't any questions, I will now give the mic, pass the mic over to Leon, and he will be talking about Kubernetes and security. Thank you very much.
So this should look better. Can you hear me?
Yes, now we can see your screen, Leon.
Ah, perfect. Okay. Then I start with the last talk of the community event. Today we are owning a Kubernetes cluster. But before, a few words about me. I work for Inovex as security specialist in Germany. And basically, I work as engineer in different projects to improve the overall security there. And my part is mostly the part of the blue team. When you talk about cybersecurity, you generally have two teams. The red team, who is trying to pen test or attack certain things, and the blue team tries to defend. And in the last projects, Kubernetes was almost always used. But also in general, container-based platforms are becoming increasingly important. But the downside is that more and more attackers are specializing to attack this kind of infrastructure. So depending on your company, this can result in a very high damage. So today we will view the platform Kubernetes from the perspective of an attacker. So that would be the part of the red team. Okay, and I will try to answer some questions during the talk, but if not, we will have time for this in the end. So let's go further. Let's check the agenda. Before we start with the live hacking part, we are going to check different points that should be considered when operating a container platform. And since there are usually always an image stacked under the container, we will take a look at how we can build this safely. We will also have a look at runtime security. And if we have the time, we will check Kubernetes resource validation. So let's get started. Here are a few points you should consider when operating a container platforms. It starts with organizational things. Then even if the finer software runs inside containers, there must be still hardware underneath. And of course, some software, for example, the Linux kernel, which controls this hardware. In case of Kubernetes, on the underlying nodes, there's more or less normal Linux distribution running, and you have to secure it like you would do it with a normal server system. Then we will look at container security, how we can enforce least privilege and image security. The next part is the orchestration management, in our case, Kubernetes. Then we look at image distribution, mainly the registry, because it's a very critical component. And just like normal science software on conventional systems, it might be wise to use cryptographic verification of your images, which are running in your cluster. The next point is secret and keys. I mean, that's a worthy target for the attacker. On the one hand, as actual target or for lateral movement, maybe even outside the container platform. We will list points over, about networking, the same with storage, and we will see how we can provide reliable audit logs and monitor this platform. So let's start with organizational things. The first step you can do is data classification. Here I got the difference between default things you can do, and if you want high security, you can provide the other things too. So for data classification, you should ensure that the data is processed based on internal classifications, and every service or application running in your cluster should have a security concept. And this application can also span over multiple containers. Additionally, you should use threat modeling to have an overview about risks and how you address them. The next point, which is really important, is especially on a multi-tenant platform like Kubernetes, is to have rules and responsibilities. That means that you have an authority that decides which base images may be used. And another point is addressing of cluster resources with contact persons. So in an incident, you know who you have to speak. If you want more security, you should introduce a complete risk and vulnerability management process. This includes, of course, a complete inventory about software, but also about third-party packages and their risk for the overall system. For example, if you use PHP packages, you may be a victim to name spoofing, which is a common attack for this kind of packages, or the library itself has a vulnerability or multiple vulnerabilities. So it's a good practice to check the library in the past. So you can just open a C4S database and see if there are any, or there were any critical vulnerabilities in the past. In the best case, your library has a professional security audit. So the next point is the infrastructure, and as on every IT system, your software components should be up to date. The majority of attacks are successful due outdated software. So you should take a look at your Kubernetes, of course, your container runtime, and additionally, you should provide hardening to it. The next point is documentation, which is also very important. In the best case, the infrastructure is automatically documented. There are tools for that, but also approaches like infrastructure as code simplifies this process. The next point are general common best practices. For example, to ensure that you have enough resources on your nodes, you provide resource limits, so a single component can't put your infrastructure down, and you should have only the software you need for your runtime. Yes, and other things like a stable OS. If you want more security, you could use something like Security Enhanced Linux or AppArmor on your nodes, one of them. And it's always a good choice to use a container-specific operating system, like not anymore CoreOS, but now Flatcar or Fedora CoreOS. Let's take a look at containers. There's the least privilege principle that's very important. So you shouldn't use root in containers when it's not absolutely necessary. And even if you have to use root, you for some steps, you should do that steps and then switch your user or drop your rights. Additionally, you should keep the no new privilege flag in mind, which prevents a privilege escalation later. And you can do here much more things like you could make your root FS read-only. The next point is the Docker socket and the service account. This is very important because this allows an attacker to easily gain access to the host. So if you can, you should mount your Docker socket read-only, and for your service account, you should keep an eye on the rights. So in Kubernetes, on the rule bindings. The next point are the image components. So generally, there's almost no reason to run SSH or RDP inside a container. You should only install the software which is really required for the runtime. So Usually you should use a multi-stage build where you compile your software in one build, in one stage, and then use the second stage to run the software without all the compiler stuff. And to keep this that way, you should also, after debugging, let the container respawn, so there are no additional components inside. And even then, you may have still too many components in the image, because do you really need a package manager in the final image? Do you need a shell or OS tools like a BusyBox? Today we will see that there are great solutions for that works without all of this, and thus significantly reducing the attack surface. Next point is that there are line tests for Docker files, just as there are line tests for source of different languages, like I think the most common is SonarQube. There are also line tests for Docker files, for example, Hadolint, which is very common. And this prevents common mistakes and promotes compliance with best practices. For example, usually you should use the copy befehl instead of the add befehl, because the add command does additional stuff. If you want more security, you could use something like seccomp to limit the system calls of your container. Furthermore, you could number the amount of processes inside your container which can be executed. This would prevent an attacker from simply spawning additional processes like a shell or something like that. The next point is content trust. That's a good idea if you want high-level security, so you only allow signed images to run on your infrastructure. Okay, let's take a look at orchestration management. Here, very important is, of course, the availability, especially of the master nodes. And if you want more security, you should only put containers with the same level of exposure on the same node. And if you use MLS, you should separate your clusters by that, because this is multi-level security, which means that a top secret process cannot run in the same cluster like a secret process. And this is important because a node can be compromised, or maybe there are side channel attacks possible. So it's always a good pattern to separate this. The next component is a registry, which is responsible for the image distribution. So it's a very important component in the overall infrastructure, because if no more images are provided, sooner or later, no more containers will run. So the registry should be definitely set up in HA, which also means it should be set up about multiple AZs. You should also ensure that the availability cannot easily be affected from malicious attacker or thoughtless users. Therefore, it's a good option to enable the garbage collection. But images provide a great advantage because you can easily scan the layers for vulnerabilities. So there are a lot of vulnerabilities scanners for images, and the registry is a really good component to do that. And many registries do that by default, for example, Harbor. Next topic is secrets. Yes, generally you should use the KMS provider for data encryption. That means that credentials or API keys should be only passed into the container using the platform solutions. In Kubernetes, it's Kubernetes secrets and not per environment variables or volume mounts. You should also ensure that secrets are not stored unencrypted in GitLab, because they are an easy loot for an attacker, especially when the write permissions are not restrictive or the project is public posted. In order to reconstruct audit process afterwards, you should have audit logs, of course, and you want them to be available for post-mortem analysis if you have to do it. So you should make sure that an attacker cannot simply delete or manipulate them, even after compromising a service or parts of your infrastructure. For databases, there's also a good solution. You could use HashiCorp Vault there, which provides rotating credentials with has to be renewed like every hour, and they completely expire after 24 hours, for example. And then you need new credentials, and you can do it by a sidecar with a tool like PG Bouncer also, which gets these credentials and provides them to your application. So the advantage is your application can speak with localhost. It does not need any credentials, but you have a great audibility for your database. The next point is network. So here, the most important thing is to use a production-ready network driver, and of course, dealing with the configuration. So not all default settings are the best one. So additionally, you can disable unused features to reduce the attack surface. And of course, every open port increases the attack surface. So even if there's actually a secure application behind, there are zero-day exploits. So it's better to limit the amount of published ports. The next step is to write network policies. For example, only allow traffic from specific ports to another port. So not every port can access other ports in its namespace. Additionally, you should provide access to cloud metadata from your ports. There's also a good repo on GitHub. It's called Kubernetes Network Policy Site, and it has a lot of examples. And you can choose an example similar to your application and then adapt it. That's pretty easy. If you want more security, you have to use something like zero trust networking with mutual TLS, so using client certificates. Yes, but that's another topic. For storage, there's literally the same. It's important to choose a production-ready storage driver and to have a regular backup of your persistent data. You should maybe spend some thoughts about FS shares on multi-tenant platforms. This can be done via OPA, that's the open policy agent for Kubernetes. So next step. Of course, you should verify that logs are shipped, and some applications may log only to files. So you can use the sidecar with Filebeat to ship that logs to Kibana or whatever. And it's always a good pattern to define alerts based on these logs. Also, you can use metrics to detect or identify suspicious activity with something like Prometheus or Grafana. So let's get to the next step. Now we're going to the life hacking part. First of all, here's an overview of a possible deployment of an app. So on the upper left, you have developers writing code. They check in their code in a VCS like GitLab, for example, and the app and the resulting image is built in the CI stage. And the image gets uploaded into the registry. You have maybe a deployment via continuous delivery on Kubernetes. And there are additional steps where you can provide image scanning. So at the first, during the build, you can do it inside the registry on a regular basis, or you can check the running images inside your cluster and check them for vulnerabilities. And here it's really important to do this regularly, because even if the image does not change, there are maybe new vulnerabilities. So here's a basic example application. This is written by myself. I used Spring Boot as framework, and it's pretty simple. Also, it's possible to add and query different entities, and they are consisting of a name and an attribute. But however, the application uses vulnerable libraries, which enable any code execution via JSON patch. It's published 2018 somewhere, and it has a CVSS score 9.8, so critical. But let's first take a look at JSON patch. So very briefly, where's the sense of JSON patch? Generally, you would have the following procedure when you want to update resources. You have to get it with your client application, you have to modify it, and you have to put it again on the server. But that would be a waste of bandwidth and computing power. So there's a HTTP patch method or JSON patch, and it offers a sequential list of operations to be applied to an object. The format depends on the resources. Here's an example. And each element of the sequence contains an operation. For example, add, remove, replace, move, copy, test, and a pointer to the object, here called path. And that's how you do the update statements. Now we will build this application. So let's list our files here. There's my simple application. There's a source code folder and a Docker file. We will have a look at the Docker file. And we see here the build stage, depending on Maven, just compiling the application. And we have the runtime stage based on OpenJDK 11, and just copies in the app and executes it. So let's try to build this image. I need to copy the registry inside. That can take a moment. I did it before, so it should use cache. So now I have to upload my image to the registry. I will use AKS to run the image later on. I did this also before, so it can skip a few layers. Then let's take a short look into the deployment. It's a simple Kubernetes deployment with this image and exposed container pod. So let's first create a namespace, switch into it. And then apply the deployment. So let's check the status. Running, that looks good. So now first I have to do a port forward because I didn't expose a public port, but that won't be a problem. So now we can check if we can reach the application. Just using curl. That looks good. So I've written an exploit for these applications with different methods. So basically I have an insert method where I just normally insert data into the application. Then I check if it's exploitable. Then I try to get the user. And finally, I will open a remote shell. So you can see here what's happening. Just a basic post request. Then here the patch request, which tries to execute a sleep command. And here I try to execute OS command to get the user. And down here, I'm building a remote shell using the TCP device. I encoded it in base 64, decoded it inside here, and then piped it to bash. Okay, let's try. First, we should insert data in here. This looks good. Let's try to query it again to see if it worked. You see here demo hacking, that looks good. So the data is inside the application. So now we can try to use to exploit it. I will measure the time. And this request or the response should take an average something about 10 seconds. And we see here nearly 10 seconds. So it seems like it worked. Now we can list the user. And here we can see we are running as root. That's pretty good. So let's try to open our remote shell. I'm in a private network, so I need a public server for that. And I will do this by doing remote port forwarding via SSH. This is a step an attacker would normally do with a hacked server. In this case, it's my own server. So all requests to the server are going to my local port. And additionally, I need to start netcat, listening on the same port. Okay. And now I try to open the remote shell. That looks good. And we instantly jumped into the container. We can list the processes here. We see the Java application running, and we see our shell. Now we can check our user via root. And an interesting thing would be the service account of Kubernetes. Let's see. That looks good. So now we compromise the container, not the whole system, but all data inside the container should be compromised right now, or we have access to it. Let's see how we could prevent this. So let's first take a look at different image scanners. Here's a basic overview about different scanners. The most common is Claire, and it's used by Cray.io, by Harbor, by Dockyard. It's generally accessible via API, so you have only the server component. If you want to use it, you need a third-party client. There are different kinds for different clients for different use cases. For example, Clar, which is focused on environment variables and optimized for CI usage. But if you want to use your normal command line, you could use Claire CLI. Or if you want to have a registry client, you can use Reg, which acts as a normal registry client, but additionally can check the images against vulnerabilities. So even here, you could use an admission controller or admission policies via OPA to prevent execution of images which has critical vulnerabilities. There's a repo with a lot of example policies based on that scanning. And what Claire basically does is Claire uses the feeds of different CVE databases, for example, Debian Security Bug Tracker, for Ubuntu CVE Tracker, or Alpine SecDB, and compares the findings against the components in the image. And we have another scanner here. It's also very popular. It's called Anchor. It also has server-client architecture, but it brings both. So there's a simple installation via Helm chart. And the great advantage that Scanner has is language plugins. So it detects packages installed via npm, pp, Python, or even Java libraries with which are embedded in jar files. Here there's also an enterprise version with users properties feeds for different vulnerabilities, but you can use the community version for free. The next one is a microscanner. This works differently. It's executed during the Docker build. It's basically a binary you download, you check the hash sum, and then it checks your image for vulnerabilities. But it has a few disadvantages. It's not open source, and with the license, you accept the upload of data to external servers. So yeah, a few disadvantages. If you use Python, you could use DuckDar. It's also written in Python, and it additionally uses ClamAV to scan your image against malware. It also has a great integration into other tools like FICO. Yes, there are two additional scanners. One is called Trivy. It's also from Acrosec, the same manufacturer as Microscanner. It's written in Go, and it has a very good CI integration. For example, there are examples for GitLab, Jenkins, Travis, or CircleCI. It also has a good integration into registries. For example, there's a Harbor plugin. Harbor uses by default Claire, but Trivy advertises that's in different points better than Anchor or Claire. For example, for Alpine, it uses Alpine Aports repo for vulnerabilities, and Claire uses Alpine SecDB has fewer vulnerabilities inside. And Anchor doesn't detect unfixable vulnerabilities. There's a last option. This is really good if you use Red Hat images, especially on UB basis. And it's using OpenSCAP, that's Open Security Compliance Solutions, which integrates into it very well. So let's take a look how different base images are doing in terms of securities. We start with the OS images. So in the table, you can see how many security vulnerabilities the 3 of the most used images have. And we see here Ubuntu has no critical vulnerability, but 17 high vulnerabilities, a few medium and low vulnerabilities. Debian even has a critical vulnerability inside per default, and a few high vulnerabilities, some medium and low. And Alpine is very good in this example. But this is also because Alpine has in its basic configuration only 11 packages installed. So the number of vulnerabilities increases with additional packages. And it has another advantage. Alpine uses musclibc instead of glibc. glibc includes a few unfixed vulnerabilities. And I think they never are going to fix, but yeah. So, but really important here is that not every vulnerability is necessarily exploitable, because maybe you can exploit it in a specific configuration of a software which uses the library in a special way. So it's not guaranteed that every vulnerability is really exploitable or really dangerous here. Even worse are the language images. For example, here Python. It has 10 critical vulnerabilities, a lot of high and medium vulnerabilities. OpenJDK is a little bit better, but also includes a lot of vulnerabilities. And the worst here is Node.js, which has nearly 20 critical vulnerabilities, about 600 high and nearly 3,000 medium vulnerabilities. But here we also can do better. There are different variants of the image. So there's also often a slim variant, which is a bit reduced and does not include that much components. And here we see it looks a lot better. And also the Alpine variant, which has no vulnerabilities. The same is for OpenJDK 11. And for Node, you can also improve the situation. Now we have a look at another project, which is very interesting. It's called Distroless, language-focused Docker images minus the operating system. And this only includes the application and the libraries which are really required for running your software. So there's non-packager included, no shell or other Linux tools. And it has another great advantage. There are plugins for Maven and Gradle. This simplifies the building process and makes it really easy for developers to build these images. Additionally, there are debug images. If you want to debug your software, they include additionally the BusyBox, or you could use, since Kubernetes 1.17, the debug feature, which shares the process and network namespace with other container, which includes the debugging tools. So let's take a look at this. So we are in the same project folder. Now we list as a Maven file, and we see we have here a plugin, the Maven plugin, with a configuration section where you provide your image name, registry credentials, your tag, some other configuration options like a port. And now you can really easily build the image. So therefore we use a container. I will mount the environment, the registry credentials inside an environment file. So I don't leak them at this presentation here. Okay, switch to the build folder. There we are. And now it's really easy. We say compile with zip build, and that should do it. Yeah, first it needs to download a lot of dependencies. That can take a while. No questions so far, okay. Now he built the image and directly pushed it to the registry. You can see it here. And that's pretty comfortable. So let's see if we can run this application or this image now. Therefore, I have a second deployment with Distroless and the Distroless tag. Okay, let's ensure we are in the right namespace. And then create that deployment. Again, check if it's ready. Container creating. Okay. Ah, perfect. Now it's running. Okay. First, we need to do the port forwarding again. This time, we need another port on our local machine, but the container port remains the same. And let's try if we can access this application. That looks good. Seems to be working. So let's try to exploit it again. Therefore, we changed the port here also for a remote shell. And again, we need to do a remote port forwarding on our server. New port number. That looks good. And now starting netcat. And same port number. So that should do it. Let's try to exploit the application again. Oh, there's something wrong. Let's take a look. No remote share, that's bad. And you see here, no such file or directory. The program bash was not found. Of course, it's not included, but I wouldn't find a normal shell in the container. And this makes it very difficult to work with this image as an attacker. So here we improved the security. And general POM XML is very configurable. So you can set JVM flags with it. You can set your arcs or entry points. You could even decide if you want your Java app in a containerizing mode or in a containerizing mode exploded or packaged. If you want it to be bundled in one jar or with class files. And this whole thing works very great for Gradle too. And besides Java, there are other distro-less flavors like Python, .NET, Node.js, or even for Go or Rust, which is static compiled. There's an image static Debian without libc because we don't need it for these programs. Yes, so there are a lot of use cases. So next step, now we are going to runtime security. We will see what we can do if we don't have protected our container before, and now we have the remote shell as attacker. That's the other terminal. So here we are. Let's list the environment variables because they are interesting, especially because the Kubernetes service host address. So we can try to speak with the API of Kubernetes. We do need an insecure flag, but we see we are unauthorized. But that's no problem because we have the service account token we got before. So let's save it in a variable. That should do it. Looks good. And let's try to make an additional request. This time using the authorization header. Therefore, we need to provide a BIRA token, which we got here. And the same endpoint. So let's try. Here we're going for kube system. Let's try to list our secrets here. That was expected. Secret is forbidden. We cannot list our secrets there. So let's try something else. Let's try to extend our permissions. This can be done, for example, by a rule binding. I saved it to a file here. That's my only possibility to do file transfer. Just copy the stuff inside. So we try to bind the cluster rule admin to our service account in this namespace. Therefore, we need also curl and make a post request, including this JSON file. And also the BIRA token is included. But Also, that doesn't work out. So that's a great list with things you can do as a attacker. There are awesome GitHub repos for that. We could also try to impersonate the user, but that also didn't work. So maybe we need something else here. We can just try to list the pods in this namespace here, in our own namespace. And we see that looks better. We see information here, especially the host IP can be very useful later. Okay. Now I have to switch. Just want to show a file. A capital. Okay, let's list the content from a shell pod, which I wrote before. And here we basically generate a pod with a remote shell using the Ubuntu latest images with a predefined command. And that's the same we used for our exploit. So it just opens as a remote shell. But here we have another thing. We mounted a path inside the container. And as path, we used a local volume mount from the root path. So maybe we are able to mount the root file system from the node inside our container. So same thing here for. Let's check if it works. That looks good. That's the same content than the file on the local system. So first, we need to do this again, a remote pod forwarding for our shell pod. I will increase the number of the pod. Looks good. And here again, we need to start netcat. Now we can try to start this pod. Got the command here. Just posted the content from the JSON file to the API. And that looks good, pending. Let's see, we got a result instantly. We opened a remote shell. Can list the processes here, and we only see our remote shell process inside. So let's see what we can find on the host system. That looks good. We see here the shadow file from the host system. We see the root user. We see an Azure user. Let's see what we can do with this. So additionally, we should check the SSHD config. If password login is allowed, but that looks bad. It's disabled. Also challenge response authentication. So we need to log in using key files, I think. So let's check his home dictionary. And that was the local pod. I need to go over the host path. And here interesting is the SSH dictionary, which includes authorized keys. Let's list up the content. One key is already registered, but it would be nice if we have our key inside this file. So we install first OpenSSH client. It should be pretty fast. And now we generate us a new key pair from type SA. No passwords, we don't need that. And now we save us the content. Let's check if it's worked. Perfect. Okay, what we can now do is to append or replace the content of the authorized key file with our new key. Here, okay, authorized keys. So let's check if that worked. That looked good. Here is the remote shell key. So now we should be able to log into the node. That the port is not exposed publicly, but we have the private port before in the pod description. So let's try this. I can't open the second shell, so I tried to pass the command directly. That did not work, maybe the wrong IP. No, I think we have to disable key verification, host key verification. So let's try to set that options, the known host file, set that to dev null. And additionally, we disable the strict host key checking, set that to no. And now we try it again. So now we can list all running containers on the host. We see here our Ubuntu. We see different infrastructure containers. We see our app. We see the network plugin. That looks pretty good. And with this step, we extended our access to the host. So we have now full access to the Kubernetes node, and all containers running on this node would be compromised. And from the node, it would be easy to do lateral movement to other nodes, to the system behind that. Yeah. Maybe the next step would be to get a nice shell on the system, because the remote shell has no auto type. So how we could have prevented this? So generally a good thing, what you can do are pod security policies. They are implemented as admission controller into Kubernetes and define conditions or defaults that pods must met. This could be, for example, to disable an auto mount of the service account token. So as a attacker, we wouldn't have a service account token to work with. But they also provide different options. For example, you can limit the host name that can be used. You can forbid to run privileged containers. You can set the read-only rootfs as default. So there are a lot of options. But what the thing that would really help us is security enhanced Linux. Which is basically a labeling system. So every process or file gets a label. Even network ports, devices, or host names can get a label. And what you do is you write rules to control the access from a process label to an object label. And this rule is called policy. And in Linux, the kernel is responsible for that. And it's also called a mandatory access control, which is in addition to the normal owner group permission system, which is called DAC. So a request has to be accepted from security enhanced Linux and DHC to work. So in older systems, you may have a web server. This technique is very old. You would have a web server of a specific process type, and you would have the files inside the public HTML folder. And this would control that the web server can only access his files. So even if it gets compromised, the web server, it wouldn't be able to access configuration files on your host system. So generally, you can use the same policy with Docker, and there are two forms of that. One is called type enforcement, which protects the host, and the other form is called MCS, multi-category security, which protects containers from another. So let's take a look here. so you have a default process type for your container, and it only has access to files which are labeled as a container file. So if I would try to access the shadow file or to write on the authorized key file, Linux would prevent this. The other point is multi-category security. It's also called SWIRT, and it adds a unique label to the field of the container. So your container type must match with the label. So there's no access between the containers. Let's check the time. Okay, go further. The next point is AppArmor, which is an alternative to security enhanced Linux, especially on distributions like Ubuntu. And it's also a security module of the Linux kernel and implements also mandatory access control. And AppArmor uses a wide list of Linux capabilities, networks capabilities, or file permissions. And you are only, or the application is only allowed to use the whitelisted capabilities. And this can be done by monitoring the applications, automatically write down what the application needs for runtime, and then forbid anything other. There are two modes of that. The first is the enforcing mode, which blocks every unallowed access. But you could also use a complaining mode, which writes the access into an audit log. So resource validation, can have a short look into this. Generally, much problems are caused by wrong configuration. So it's a bad thing if the workflow is privileged, so the container can have fully access to the host. It's also bad when the container is running as root. In the past, there were several exploits which were only possible when your container was running as root. So then you could exploit the Docker daemon and get access to the host. Very dangerous tool is the CapNet raw capability, which allows the crafting of network packages. You can do ARP spoofing or ping of death or things like that. And there's a tool which checks all these configuration things. It uses KCCS. That's also a risk score from 0 to 10, for 0 for no risk and 10 for high risk. And it's similar to CVSS, but it focuses on configuration and security settings in Kubernetes. And you can easily deploy the application in Kubernetes and access it via web UI. And that's how it looks. It detects different problems like the net raw capability in containers. We will have a short look on another tool. It's called KubeHunter, also for Acqua security. And it's basically to hunt vulnerabilities in your cluster. So you have two options. You can use a remote scanning if your cluster is accessible via network, or you can run it inside the cluster like you would do, like in the case with a compromised container. KubeHunter detects different vulnerabilities. Here's a short list. There are also Azure-specific vulnerabilities or exposed dashboards, for example. Yeah, that's very good to have an overview like this. Okay, that was it so far from my side. Are there any questions?
So it looks like there's one question. Leon. Do you see the question?
Yes. Can you name some tools for automatically documenting the infrastructure? It depends on the infrastructure. So if you use cloud resources, it's pretty easy, even when you use tools like Terraform to deploy your infrastructure. For Kubernetes, there's tools which are called Tire, which is optimized for documenting network infrastructure. But it depends on the platform.
Any other questions? So Florian and Nico are also still on the call. If you have some more questions for Florian and Nico. So if not, I would like to say just a thank you to all attendees, especially thank you to all speakers, Nico, Florian, and Leon, who are still on the call. Also thanks to Moritz, who did the first DevOps talk. And I hope I will see some of you soon in another virtual meetup, or hopefully in an in-person meetup very soon. Thanks all. Take care. Stay healthy. Bye-bye.